All right. Hello, everyone. My name is Amir Agakuchak from University of California, Irvine. And on behalf of the Planning Committee, I'd like to welcome you to this workshop on climate change and human migration and Earth system science perspective. I'd like to extend my gratitude to each and every one of you, including online participants, for joining us today. We know you're all very busy, and we really appreciate you spending your time with us and sharing your expertise. The topic of the workshop is motivated by a series of Academy workshop and reports, mainly funded by National Science Foundation, including this report on the next generation of Earth system models. And I've highlighted just the one passage from this report, highlighting the fact that we need models that ideally represent both natural and social processes that affect the Earth's capacity for sustaining life. Climate change and migration represent two interconnected phenomena that are reshaping societies and ecosystems around the world. The impact of climate change, from rising sea levels to intensifying storms, are forcing communities to confront the reality of displacement and relocation. The importance of this topic cannot be overstated. It is not merely something for the future. It is a reality that millions of people are facing today. Given the interdisciplinary nature of the topic, the Academy has put together a diverse planning committee to organize this event. I'd like to thank all the committee members who have worked really hard to shape the content and structure of this program. To organize our thoughts and discussions, we have divided the program into 5 sessions and also a series of keynote speeches. As you can see from the program, we are interested in climate change and migration across a broad range of time and spatial scales, including migration in response to individual events like hurricanes and droughts, and also migration in response to slow changing conditions like rising sea levels. We are also interested in global and also local scale migration and displacement. The workshop provides us with an opportunity to deepen our understanding of these complex dynamics. But more importantly, we would like to identify and discuss key gaps and opportunities in our existing models, tools, and data used both by physical and social scientists working on climate and migration. We hope that by coming together to exchange knowledge from different perspectives, we can highlight opportunities for advancing the field. Some housekeeping rules. The committee encourages each and every one of you to participate in the discussions, including virtual attendees. Your insights and perspectives are important as we seek to advance our collective understanding of key gaps and opportunities. Please direct your questions to individual speakers and not their organizations. Of course, the ideas shared here are not the opinion of the National Academies, but more opinion of individual speakers. And the full workshop will be posted on the workshop website. A written report will be published in a few months. And finally, on behalf of the Planning Committee, I'd like to thank the National Academies staff for organizing and facilitating this event and bringing all of us together. I wish you all a great and productive meeting. And thank you so much again for joining us today. With that, I'd like to invite Dr. Alexandra Eisern from NSF to give her opening remarks. She's the Assistant Director at NSF Geosciences. Thank you.
Thank you so much. I want to thank you all for the opportunity to just say a few words at the start of this symposium on climate change and human migration. The Foundation's very excited to be a sponsor of this event, as it's really going to provide the opportunity for you all to have the space to explore the intricate relationships between climate change and human migration, but in particular through an Earth systems perspective. The outcomes of your discussion are really going to be critical for helping us having you map future research needed to advance understanding and predictive capabilities to develop a more effective policies related to human migration, but also for us, helping us map future investments needed to achieve those goals. As was mentioned, this is the third in a series of follow-on activities from the NASEM report that you were just shown on next generation Earth system science. This report was released in 2021 and has really been a roadmap for us in the last few years. The two other workshops that were also supported were on tipping points, cascading impacts, and interacting risks in the Earth system. And the second one was climate intervention in an Earth system science framework. So including this activity, these three are very important to us as we look forward. There's also a separate follow-on activity related to these three workshops, and that's the roundtable on macroeconomics and climate change, or macroeconomics and climate-related risks and opportunities. That's supported in part by NSF, but also by other foundations. So as a sponsor, these activities are really important because they really allow us to hear from you and gather a broad perspective on the many ways that climate change is influencing society. As I mentioned, at NSF, the Earth System Science report that NASEM released in 2021 has really been a guiding framework, helping us not only frame a series of funding activities focused on research, translation, and innovation that are closely linked to NSF's cross-cutting agency theme, Build a Resilient Planet, but also helping us look at our own organizational structure within the geosciences. Through Build a Resilient Planet, the Foundation, that framework is helping us make significant investments in climate change research and clean energy technologies. And as we were developing this theme, we really focused on creating an integrated approach to engage scientists and engineers across disciplines, really with the goal of advancing knowledge, empowering communities, and generating innovative technological solutions that address the societal needs in creating resilient communities, which is really at the focus of what this workshop, or is part of what this workshop is looking at. As part of the Build a Resilient Planet agency theme, the Geoscience Directorate has released several Dear Colleague letters, which are really just letters that help focus community attention on areas of priority research that we would like to see proposals on. And these topics include understanding and predicting the compounding effects of hazards and extreme weather events and climate events, research at the intersection of climate change and human health, development of new technologies to advance Earth system science research, the science, governance, and consequences of CO2 removal and solar radiation modification strategies. And also, another area also related is the discovery, characterization, extraction, and separation of critical minerals that are needed in many of the clean energy technologies that'll be important to creating a more resilient society. Other exciting additions to the Foundation's investment in climate resiliency have recently been announced through the Directorate for Technology, Innovation, and Partnerships, their Regional Innovation Engine program. Of the 10 new engines that were awarded, 4 are really closely related to changing environmental systems. So one was the Colorado-Wyoming Climate Resilience Engine. We also supported was the Great Lakes Water Innovation Engine, the Southwest Sustainability Innovation Engine, and in North Dakota, the Advanced Agriculture Technology Engine. So these engines are really going to contribute to the portfolio of investments that we're making in this space. As I mentioned, the Earth System Science report also really made us think about our internal structure in the Geoscience Directorate, and in recognition of the importance of Earth system science in facilitating a holistic approach to studying our planet, we established a new division in GEO called the Division of Research, Innovation, Synergies, and Education, or RISE. The major goal of RISE is really to foster transdisciplinary collaborations that engage the broader geoscience community, but again, with a focus at Earth system level research. Right now, our goal is to have flexibility in the RISE division. And right now we have 5 key incubators. One is around geoscience, education, and diversity. One is cyber infrastructure, geoscience innovation, global climate challenges, and also synergistic activities within and external to the foundation. So really helping us build partnerships, not only with our traditional agency partners, but also with philanthropies, with industry, et cetera. So RISE is really going to help connect the geoscience community to drive transformative discoveries, but also innovations in workforce development and use-inspired solutions that really are aimed at addressing urgent Earth system challenges, such as the one you'll be discussing here today. So as I mentioned, we're very excited to support this workshop. We're obviously, as you're all well aware, we're seeing clear evidence that climate change is exacerbating environmental stressors such as water scarcity, extreme weather events, compounding environmental hazards, sea level rise, and it's also affecting disease vectors. And these changes are particularly impacting those that are least able to adapt, creating significant disparities in climate equity, with vulnerable populations such as low-income communities and indigenous peoples being disproportionately affected by climate-related displacement. So policies focusing on climate resilience, sustainable development, and social justice are essential for mitigating the impacts of migration and supporting effective communities. However, to develop sound policies, we need researchers such as yourselves and activities such as this to help us identify research gaps and really advance predictive capabilities to better understand the impacts of changing environments on human migration. Activities such as this will also help the foundation make sound investments that benefit society with the basic research needed for such things as developing early warning systems, improving disaster preparedness, and importantly, developing resilient infrastructure needed to reduce the need for migration by enhancing local adaptive capacity. So I would just thank you all for being here and spending time out of your busy schedules. The work that you'll be doing over the next 2 days is really critical for our resilient future. So thank you from NSF.
We don't clap. Good morning. As I begin introducing myself and introduce the panelists, keynote speakers, I would like to request our keynote speakers to come and join me on the podium here. Professor Justin Mencken from Dartmouth College, Professor Laurie Hunter from University of Colorado Boulder, and also part of the planning committee, and Jackie Schaefer, who kindly agreed to fill in for Melinda Chase, who had a personal emergency and is not able to join us. Jackie is also part of the planning committee of this workshop. My name is Kilaparthi Ramakrishna. I'm at the Woodsole Oceanographic Institution. I'm the director of the Marine Policy Center. If there is one thing that I spent much of my life, both as an academic and as an international civil servant, it is working on climate change. And when we talk about the climate impacts and the impact on humans in terms of the migration and what have you, time and again, the policies that are advanced did not have the benefit of what a group like this can advance. And so this is really quite an important exercise, not just in terms of things that I had done, which are largely at the international level, but as Alexandra pointed out, building resilience, at the community level. Right now, I live in Woods Hole, and the sea level is a major part of it. And how do we build resilience? How do we make sure that businesses and communities that live and depend on the coastline are able to cope with the changes? And what role should the state play, and should the international community play, and so on and so forth? So I'm really very pleased with the keynote speakers that we have here. And as I mentioned to you, two of them are part of the planning committee, and they are really well versed in these topics. I am not going to go through the introductions of each of our panelists, and I would ask them to say briefly, what it is that they are taken by this issue and the work that they had done so far. Before I hand over first to Professor Justin Mankin, I would, you all know that he's from Dartmouth College, and he's going to say a little bit more about himself shortly. As Amir, the chair of the planning committee, had mentioned, we have quite a sizable number of online audience as well. So once the presentations are over, then we will open it up for discussion, both for folks here in the room as well as online. So I would come back to you with reference to anything specific about the modalities at that stage. The planning committee had outlined a set of objectives for the keynote presentations. I would want to just read out that quickly and then hand over to Justin. The idea of the keynote session is to frame the discussion of climate change and human migration from various perspectives: Earth system modeling and social sciences. This session will provide an overview of Earth system science, social science, and practitioner approaches to climate change impacts on human migration, and B, the current state of knowledge and research gaps. That is the most important part of it, and I'm looking forward to learning as much from this panel as many of you here in the room and online. So without further ado, Justin, you have the floor.
Okay. There, if that's good.
Yeah, sure thing.
This, am I able to advance it here? Cool. Morning, everyone. Thanks for having me. Thanks, Kilaparti and Amir, to the planning committee for having us here, and also to Maya and Lily for all of your work to make this happen. It seems like it's going to be a generative meeting. I wanted to set some context for how I've been thinking about climate migration. The obvious starting point for me is the climate system. 2023 is now known as the hottest year on record. And given how January and February of this year have gone, it's essentially a coin flip as to whether or not 2024 will also meet or exceed that 2023 record. So warming is on the march, and people are taking notice, right? This is a figure here from one of my graduate students, and it's just showing you the number of news article mentions of record-breaking heat, right? So quite literally, we're seeing an acceleration in the remarkability of global warming. And at the same time, we're actually experiencing those impacts now, right? So this is a time series showing you the record ratio, right? So essentially the ratio of the number of records an individual experiences, agnostic of where they are on Earth, relative to the number of records they should experience given the period of interval over which those records are evaluated. And you can see that this line is trending upward, meaning that we are having more records, daily temperature records from global warming. And there's a lot to unpack in this figure, but I want to point you to the two stars at the end here on the right. Essentially what that's showing you is that a person born in 1950 has experienced over a year's worth of daily temperature records, right? So over a 75-year interval, it took that 75 years with global warming to experience something like 365 brand new novel temperature records for a time and place, right? A person born today can expect to reach that threshold of a year's worth of additional records in the next 25 years. So impacts abound. And we are just beginning as a research community to grapple with the costs associated with them. So this is a figure from another graduate student of mine, Chris Callahan. And what we're showing here are the cumulative economic losses in terms of GDP change from global warming driven extreme heat over the 1992 to 2013 period. And you can see that we estimate, based on our econometric modeling, on the order of about $30 trillion worth of global macroeconomic income losses due to the extreme heat that we can fingerprint back to global warming. These costs are astounding. I think the other context here is that we are poorly adapted. It's not simply global warming. I think we are poorly adapted to climate variability as well. So this is a figure showing the set of El Nino forecasts beginning in March of last year, of 2023. I've highlighted in pink the magnitude of the El Nino as of December, January, February of about 1.5 degrees. So quite a strong El Nino event that's occurred and is now waning in the tropical Pacific. We have also estimated and predicted the economic costs associated with this El Nino event, and we expect by 2029, 5 years from now, losses from this form of climate variability to be on the order of between $4 and $5 trillion at the global scale, disproportionately impacting the most vulnerable among us. So it's not simply that we are vulnerable to warming, we are also vulnerable to climate variability, absent any effect that warming has in terms of altering climate variability itself. And this is all happening within a wider geopolitical context and context of social upheaval, where people are moving and have long moved in order to manage their exposure and to manage stress. 1 in 75 people, according to the UNHCR, face social disruptions that force them to move in 2022. More than half of those are internal displacements, and that is an astounding state of reality. So that is the context in which I kind of start to think about climate and migration. And so what I want to do today in the rest of my remarks is I want to consider two things. First, I want to consider the merits of developing an Earth systems perspective on climate migration. And second, I want to annotate what I see as some of the challenges to doing so. So on the first, so I think of the value of an Earth systems approach as being one that thinks about the coupled dynamics of a system of inquiry, right? One in which you can evaluate residence times and feedbacks and really untangle some of the dynamism in some kind of coupled system. And I think of an Earth systems approach to climate migration as being an element in a much broader effort of more meaningfully endogenizing people into models of the climate system. And so what I'm showing you here is just a schematic diagram of how I think about this. It's not the only way to think about it, but where you have some kind of climate forcing on your left, inducing some climate change. That's that delta climate, inducing some set of impacts that alter human well-being, inducing some human response, that's that circle at the top there. And that human response can come in myriad forms, right? And is projected onto a very complex socioeconomic landscape and cultural landscape. But you can imagine that some of the activities that we undertake in response actually just kind of diminish our risk of exposure to climate impacts and wouldn't necessarily alter forcing. But you can also hypothesize scenarios whereby that human response actually manifests in altering the forcing and is a full actual feedback to the climate system, right? Mitigation is the obvious one, but I also think that there are emissions embedded in adaptation itself, right? Seawalls, should they be constructed, are going to be coming from concrete, and to the extent that that concrete is linked to fossil fuels, that's going to have a fingerprint on warming. I also think that migration itself, to the extent that you have out-migration across borders, and you have the potential for degrowth, you could actually see degrowth in some scenarios enforcing sets of temperature targets. And so for me, I see a value from a climate projection perspective of more meaningfully endogenizing people into models of the climate system. I also think that if we're interested in informing sound interventions to manage the risks of climate change, like mobility, increased mobility and migration, we want to understand the extent to which there's a fingerprint of warming on those processes. And then more widely, and this is kind of my own personal motivation, I am really interested in understanding the costs of climate change to date, and the equity and justice issues embedded therein. And so endogenizing people, and in particular models of climate migration, into our understanding of the climate system writ large, I think is essential for understanding the true costs of warming to date. And so I think this stuff is actually quite powerful. You know, it allows us to do stuff like this work that I'm showing you here, which is not yet published. What I'm showing you is that we are actually able to quantify the particular harms that have occurred that are attributable to particular emitters. And this is kind of an endogenizing framework that allows us to go from emissions to impact. And so what I'm showing you here at your left is an estimate of the economic damage wrought by the extreme heat attributable to the emissions of these individual fossil fuel firms, right? So I'm showing you that Gazprom, for example, we estimate has caused about $1 trillion in economic losses globally from their emissions profile over the 1991 to 2020 period, right? And we can actually do this at finer spatiotemporal scales, as I'm showing you at the right. And it does not take a genius to see the embedded inequities in that map, right? Where those redder areas are those that are least culpable for global warming, that have the least resilient economies to like improve their adaptive capacity for global warming. And they also happen to be the places where we have the least data to actually inform meaningful interventions. So with that, I want to kind of turn to the challenges that I see to meaningfully integrating a kind of an Earth systems approach to something like climate migration. And we can, you know, start with a kind of maybe trite observation that integrating across disciplines is hard, but that's what this kind of activity necessitates from us, right? And so you can imagine a framework that I'm showing you here at the left that goes from climate changes to some kind of second order indirect impacts. And it naturally is going to have to start to bridge across disciplines from the natural sciences to engineering to the social sciences. And we can kind of posit what I see as some of the challenges here, you know, for a kind of a cartoon example where we have temperature changes inducing some kind of agricultural loss. That agricultural loss has a meaningful fingerprint on people's well-being, and that leads to some decision point. And maybe that decision is migration, right? But the challenge of moving down that cascade and really kind of disentangling causality requires reconciling different spatiotemporal scales, different characterizations of uncertainty, very different forms of prediction across these disciplines, very different levels of comfort with abstraction, right? What is that sweet spot between specificity and generalizability? Is it the case that these models necessarily need to be reductive? And if so, what level of reduction is acceptable? And then the thing that I want to just kind of end on here is that data becomes more limited and elusive. And so let's just spend a moment on that. So maybe not we, but I want to know the social impacts of climate change. That's why I'm doing the work that I do. And to make these assessments, we need data. And those data are often unavailable, or where they are available, they come with uncertainties from the analytical choices that generated them. And I think it is very clear that data gaps map to the most vulnerable and exposed among us, implying that we are systematically underestimating the impacts and thus the costs, and thus the potential for meaningful interventions to respond to climate inaction, and that this is something that is among the most vulnerable. This, to me, is a really salient example of that. This really concretized, you know, data emerge from an existing system of power and profit. This is work that I did with my graduate student, where we showed how global warming is affecting home runs in Major League Baseball. A totally ridiculous study, a really fun and wonderful study, but one that I think belies the epic tragedy around documenting the economic toll and social toll of global warming, right? We were able to do this, estimate that each Major League Baseball season has about 50 additional home runs and projected down to the ballpark level, owing to global warming, because Major League Baseball is self-obsessed, right? Because we had 240,000 individual batted balls where we had the launch angle and launch velocity, and we could compare them on a warm versus a cool day and get that kind of empirical control. Like an astounding thing. Data limits us in fundamental ways. And I wonder, what are the things that we cannot track owing to data limitations? Data collection itself is a function of the privilege, priorities, and values of the data collector. And I think this billion-dollar industry of Major League Baseball really drove that home for me when I did this study. We know and have long known that there's data poverty on the social side, right? You know, the return interval for economic surveys or censuses are not sufficient in order to get resolution on how people are managing and experiencing climate stresses, right? But I'd also argue that once this slide comes in, that data poverty also exists on the physical side, a place where we normally think of having data plenty or a surfeit of data. And you can see this in these two maps here, which are showing you the distribution of meteorological stations around the world in two major data sets that we use to track temperatures. You'll notice that the observations are not uniform in space. And you can look at those data in another way, where this is just the number of meteorological observations that you have in a particular location relative to the global mean. And it really makes salient that there is an embedded inequity in the amount of data we have on the geophysical side, right? North America and Europe are places of data plenty. You can see that South America and Africa in particular, and then parts of Middle East and South Asia, and also the interior of Asia are really struggling from a data perspective. And more widely, once this pops up, this is another way to kind of think about this. I'm showing you the number of weather observations given the underlying population density at a location. And what you can see with the zonal means at the left and the right here is that there is a very clear latitudinal structure here that maps on to the acids of the post-colonial world, right? What we see is that we have highly populated regions with low GDP relative to the global mean without weather observations, meaning we are unable to track climate impacts in the places that are least culpable for them, are experiencing them first, have the fewest resources to manage them, and we have the least data to even kind of articulate what those impacts are and therefore help them develop management strategies. So with that, I think an Earth Systems perspective on climate migration has incredible merits, but it first must help articulate and rectify data gaps, lest it reinforce overly reductive and deterministic models of human tragedy. So with that, I'd like to thank my funders and also my collaborators, my graduate students, Chris Callahan, Alex Gottlieb, Maggie O'Shea, and Flora Perlmutter, without whom this work wouldn't have been possible.
Thank you very much, Justin, that you really set the stage very nicely. Not only did you talk about the importance of this exercise, but, you know, by bringing about the directness, the causality, which is oftentimes the central issue in litigation, you know, which is now gaining in numbers, and we will come back to this in the discussion time. So my request to all of you is to hold your questions till all the three presentations were completed, and then ask your questions. Now I would invite Professor Laurie to make her presentation. Thank you.
Thank you very much. And Thanks, everybody. And again, thanks to the organizers. I love your talk, Justin, and I hope that mine is a good follow-on. What I'm going to do is talk you through how migration researchers do our work. For those of us in the room that do this work, this will be repetitive. But I think it's really important when we're thinking about how can we take what we do and integrate it into Earth systems models to think more about how we do what we do and what kind of gaps there are on our side. So I will do this. I'll talk about migration as a complex social process, think about data sources, different kind of approaches to the way we do our work, what's missing, and what kind of data needs we have on our end. So first, migration as a social process. Again, to the demographers in the room and online, this will be old news, but I find this graphic so instructive and helpful in talking through the different drivers of migration. So you'll see here, there are micro level drivers, right? We know patterns related to migration in terms of age, education, wealth, marital status. We also know that there are meso level factors, things like social networks matter a tremendous amount. Policies matter a tremendous amount. We next think about macro. So now look at the left-hand side of the graphic. Political drivers, demographic drivers, economic drivers. These are also larger scale contextual factors that shape with and interact with those other micro and meso factors to influence migration. What was nifty about this framework when it came forward is it was the first one to really think explicitly about environmental impacts. So sure, there's these acute impacts, right? Hurricanes that displace people. But importantly, environmental factors, heat waves, drought, interact with all of these other processes to influence migration decision-making, right? So environmental influences impacting economic opportunities and so on. But I hope this gives you a sense of the complexity that we're dealing with when we think about migration. Scale, Justin mentioned scale. We have to think about this too. Individuals making migration decisions are embedded in households or who are embedded in communities, who are embedded in counties, right? All of those factors, the macro, meso, and micro, are things we need to think about when we're modeling migration decision-making. You can see why this makes projections really challenging. So when people ask us to think about the future of climate-related migration, it's tough, because modeling this is tough. Groundswell was a report put out by the World Bank several years ago. Alex Desherbinen and perhaps others online were involved in this, where they developed amazing models to try to project climate-related migration. They did so only for internal migration, meaning within countries, because that also bounds it in a way that's a bit more manageable as well. But they projected 140 million individuals moving within their countries by 2050. So there's migration as a complex social process. Let me think about data sources and research approaches. So Justin also mentioned data integration. So we've got great social data over here, right? Age, education, and gender as related to individuals. Now we've got some environmental data over here. Maybe we know about extreme events. We know about temperature. We know about precipitation. We have to find that middle space where those come together, right? So perhaps that's related to, I can give you an example from my own work. I study migration decision-making in the US. People move across county boundaries. We've defined it that way. And so I want to know about what extreme events have happened in that county, right? What kind of drought or heat waves have happened in that county? But that county becomes the spatial scale at which we need data, right? And then there's the temporal scale as well. So somebody's moving. Are they moving as response to an extreme event that happened last year? Are they moving in response to extreme events that have happened over the past 5 years? Are they moving because of cumulative? Are they moving because of scale or scope of the events? In my work in rural South Africa, does it matter if there have been 3 years of drought? Does it matter if there's been, so you see what I mean, there's cumulative. So the temporal scale needs defined in addition to the spatial scale. And we need that integrating space in between. So let me give you some examples. Some work using population censuses. So we do have censuses from across the globe that can be useful in this way. I studied migration Mexico to the US. We use census data from the Mexican census 2000 and 2010. Oftentimes census bureaus give you a percentage sample, random sample, because there's too much data in a census. So we linked this with all sorts of information at the community scale and basically found that outmigration from drought-stressed regions of Mexico was prominent, but only for spaces, communities that had very strong social networks in the United States. So we were modeling again migration decision-making at the individual scale based on individual characteristics, household characteristics, and characteristics of the community using census data. One challenge here, when you use census data, they often say, do you live someplace different than you lived 5 years ago? So when we think about temporal scale, so we don't know within that 5-year window when somebody moved. So we end up having to connect environmental data that basically covers a longer time frame. I'm saying this because ultimately this is to think about what kind of information could we use from the Earth systems community to better do the work that we're doing. Another example is surveys. So there are actually a lot of surveys out there that we can use to study migration. Catherine will talk about one tomorrow, and she talks about Catherine Donato, and she talks about transdisciplinary research. This is an example from scholars at the University of North Carolina, Chapel Hill, who've been doing a long-standing survey over 20 years in a small district in Thailand, and they study outmigration, and they study it as related to the characteristics of the land parcels that households have access to. So you've got individuals, you've got households that are making migration decisions. You've got information on drought, which was key for them because this is a rice growing region. So what kind of changes have there been in the rainfall? And they attach those together to characterize the plots that the households had access to. And then they modeled migration, both whether or not somebody a household sends a migrant to an urban area, say to garner some income, and whether or not those migrants come back. So that's circular and seasonal migration. What they found was climate-related stress in the communities reduced return migration. So individuals who had moved were less likely to come back, but it really had no impact on outmigration. But that's just an example of the kinds of work that we do with surveys. There's a lot of this kind of work with surveys. Just one example from rural India, they used the Indian, I can't remember the name of that survey, but another one on temporary migration and climate variation in Eastern Africa, they used the Living Standard and Measurement Survey. So you actually find a fair bit of work on that. And there are surveys and different kind of censuses that are available to researchers to do this kind of work. Not to say the migration data is always exactly what we want, but there is information out there. The last sort of framework or analytical framework I'll talk about is ecological analysis, where you might characterize different spatial units. So this example here from Matt Hauer in Florida, he looked at counties across the US, characterized counties as related to sea level rise, so bringing in the climate models there, and then thought about what kind of migration flows might we expect at the county scale as related to sea level rise. But he wasn't characterizing individuals like I've been talking about thus far. He was characterizing spatial units. So that's considered more of an ecological analysis. I'll quickly run through what it is I feel like we know. So environmental pressures come in a lot of forms. They intertwine with economic, cultural, and other factors. Migration is only one among all sorts of different adaptive moves not moves, that's a bad choice of word, adaptive activities that households can make in terms of climate. And it would be really useful to have more information on the different adaptation strategies. Dry spells in regions yield more outmigration, but actually in some spaces, when you've got more or sort of more abundant resources, that can fuel migration, which is not what we think about in terms of climate-related migration. But households that have access to more resources might actually be better off, such that they can afford to send somebody elsewhere, right? So this is a livelihood strategy, sending someone from your household elsewhere to garner income. It's not always scarcity that does that. Sometimes it can be surplus. Let me talk a little bit about what's missing. So amongst migration researchers, myself included, we think a lot about what pushes migrants, right? So part of what pushes migrants are maybe environmental challenges. We don't think so much about what pulls them, right? So in our data, we often have information on where they are, not so much where they go to. And so when we're thinking about the kinds of work we can do together as communities, I think that's one space. We also don't know a lot about agency. So this is more what we need on the social science side, but you can imagine in some cases, Hurricane Katrina, right? Or typhoons in the Philippines, displacement, an acute disaster that means people have no choice but to move. There's no agency there, right? There's no volition. Amenity-seeking migration, on the other hand, right, is when people might just decide to move because they want to seek a different kind of lovely environment. So that's very voluntary movement as related to environment versus involuntary movement as related to the environment. Someplace in the middle might be livelihood mobility or livelihood migration, right? So households have tried all of these different things. They've tried different crop varieties. They've tried different timing of planting, you know, in response to weather pressure, but it's not working, right? And so they end up having to move. So that has a little bit of volition, but not entirely, okay? Another thing that we're starting to study, but I think is also important when we think about Earth systems and vulnerability, and is people who don't move, right? Some households can't move. Some households don't want to move. They're still vulnerable if they're in a space like that, but we don't study them as much. What's also missing is qualitative insight. We're going to hear, I'm so thankful, from Jackie after me about Indigenous perspectives. Let me just say that throughout the workshop, it would be great to think about how do we bring those critical life experiences, across generation experiences, into what it is we're trying to understand. We have to do it, and it hasn't been done well thus far. What I also think we need, again, this is Alex did some work, is connection to policy and decision makers. We're not good about that either. How much would I love to know what questions policymakers need answered, right? Instead of being fueled by academic curiosity, I want to do some work that's getting people the information they need to make the decisions that need to be made. We don't do well talking across those communities. There's lots of things on the social data side that I think we need, but I want to go through that kind of quickly. It's hard sometimes for us to get access to the codes that allow us to put analytical samples into place. We need to know the counties where people are living in order to make that connection. That's not always easy to find. Boy, wouldn't we love larger sample sizes. It'd be great to standardize some measures. Migration is sometimes measured as across, say, a county or from country to country, or so there's a spatial dimension to measurement, and there's also a temporal dimension to measurement. Where'd you live 6 months ago, last year, 5 years ago? So we have to pay really close attention to measurement, and then follow up in destinations, and it'd be great to understand what other kind of livelihood options. But most is related to this group here. This is from a review by Hoffman et al. In 2021, and they went through some recent work on climate-related migration and identified what environmental dimension those studies really engaged. You can see here, we think a lot about precipitation, we think a lot about temperature, and a little bit as related to the other kinds of things. But what we really need is accessible measures with flexible scaling. So we go out to different climate-related data sets and mush things together to characterize, for example, an average temperature for a county or an average temperature for a municipality in Mexico. And then we might look at, okay, well, have there been anomalies in the last 5 years as related to a climate normal? And that's how we measure environmental things. It would be great to have some flexibility and easier access to some data. What we also don't know and haven't done a great job sort of reaching across disciplines, in my humble opinion, and this is just my opinion, is of course, anomalies in temperature are important. But what's really important to migration from rural Mexico is when do we get to a temperature where the corn, the maize is impacted, right? So what are those mechanisms or those pathways that lead to migration? So it's not just whether or not things have got warmer, but when have we hit a threshold at which households no longer have a choice? Justin mentioned uncertainty. There's a lot of uncertainty, I know, in that climate-related, environmental-related models. How do we bring that uncertainty into our models in a way that we understand the propagation of that uncertainty through what we do? And let's go to the other side. How do modelers there think about the uncertainty in our models, which there is a lot, right? So how do we bring these together and understand the uncertainty that intersect in that space? And then education, really just, I love that we're here in this room and that we're all online and that we can think about what it is we can both bring to the table and how might we better do that. So talking to each other. So I will end with this question as related to Justin's. What is needed from us? How can the migration research community better provide information to the Earth system science community, right, to do our work better? We need to know that because we're not really sure, or at least I'm not. How can migration information, our understanding of this complex social process, situate in the work that you do? Talk to us, because that would be great. And I'm so excited that we're here. I'm not sure that we have the same level of data poverty. There is some, boy, would I like more. But I think what's important is that these communities come together and really think about what has been done and how we can benefit from sitting at the same table. So I come back to this framework just to ask this question. I hope that in the last 13 minutes, I have convinced you why it is so hard on the migration research community when people say, can't you just tell us how many people are going to move because of climate change? Not so simple. So thank you very much.
Thank you, Laurie. Very challenging set of questions. And, I said in the beginning, I've spent a lot of my time in climate negotiations and the Intergovernmental Panel on Climate Change. And one of the questions that oftentimes the scientific community is faced with in the IPCC context is not to tell the policymakers what they should do. It should not be policy prescriptive, but, provide options. But one of the things that you were asking is really, well, asking the policymakers in turn to tell you what it is that they need. A very interesting way to look at it. Our final speaker is Jackie Schaefer. Before she takes the microphone, I just want to encourage you to put your questions online, those of you that are online, and also those that are in the room, be ready with your questions, and we will begin this discussion soon after Jackie's presentation. You have the floor.
Is it okay if I just sit here? Okay. I don't have a slideshow. because this was very last minute. Vlalotak, Vanga Atika Catalina, Nalakmitska Jackie Schaefer, Inubenanga, Aniwanga Kikikagrami. I am Inibak and I was born and raised on the northern coast of Alaska. And I like to introduce myself in my traditional language because there are a lot of English terms, especially when it comes to the science and research world, that do not translate into our languages. Alaska is very vast, so it's very difficult to, when I listen to international conversations, that's how Alaska is. If you impose Alaska over Europe or over Asia, that's how complex our communities are. But we are very small in population. And so we have 229 tribes that are federally recognized. Our forest location was, in Western contact, the US government forced our communities to exist on the lands they exist on now. And this is important because in that process, they came in the summer months and we were seasonal migrational people with our food systems, which we still are, but instead of migrating with the animals and the plants and the seasons, we now are isolated and we migrate out and come back in and create this impact on one isolated geographic spot on the planet. And so every single community is either on a coast or on a river system because they came in the summer on ships and they saw people who were gathering, their summer fish. And unfortunately, every community was placed on fragile ground. Alaska is the only reason that the United States is an Arctic nation. This is important because on a global scale, the circumpolar north is a regulator of our planetary. We have polar caps for a reason. We have to remind ourselves sometimes that we are missing the philosophical piece of our elders tell stories and remind us that we are on a planet suspended in space, controlled by a sun and a moon. And so when you think universally and you span out, it really puts things into perspective. In order to keep the balance, we have to understand the system. And so as an Inupiaq from the Northwest Coast, when I got into this work, it really was looking at how do we help share the story of this interconnection and this harmonious stance with nature. In my case, for 500 generations, we have lived on the same geographic spot on the planet. We have not migrated. We still eat our traditional seasonal foods that my ancestors ate. Why is this important? Because there's much to learn from people who have adapted over time. Even though our history was oral history, those stories are compelling when you cross them into science. And so it again bridges these two worldviews and these ways of thinking. And I think you could probably do it in other indigenous populations that live on the planet that have lived there for long periods of time. We live in a Western mindset that kind of compels us to just live with whatever Western things we've learned. And we sometimes forget that every single one of us had ancestry somewhere on this planet that was not. Well, for me, it was in the same place, but for you, it may not be where you live today. And so the movement of people has to be interconnected side by side with the movement of the animals and the other living species, because they usually tell the story before an event happens. And if we don't pay attention, we as human beings will miss it. And so that interconnectivity with nature and with the environment is really, really important. And so I really hope that if anything, I plant the seed of curiosity and help you to understand the world perspective and the worldview that I come from and why it's so important that we share this across the globe. Most vulnerable populations don't get the opportunity to sit in spaces like this and share this. And so it's really important to me. I never come as Catalina myself. I come serving all our 229 tribes and all the people that live in the state of Alaska. Of those 229 tribes, 144 of our communities are environmentally threatened. I would say that probably in Alaska, there is not one community that isn't being impacted by the changes of that are happening and occurring due to climate. Alaska is warming. Now we are uncertain, but 3 to 4 times faster than anywhere else on the planet. So the impacts are real. And that reality in those communities with small populations, but deeply rooted into that geographic space, are compelling stories because they have in the past been able to migrate with the animals and the plants and the seasons very naturally in this stance with nature. What we have now are regulations and land ownership and land base that confine us. So one, we don't have the privilege of time, and two, we're confined by governmental policy and processes. When decisions are made here in Washington, D.C. by people who don't understand that interconnectivity, it's very hard for them to be appropriate, not only for the people and the culture, but for the environment itself. I like to use examples. We have a village that I visited in February a couple of years ago on the river. And this community, was colonized or westernized, but not modernized. So they lack water and sanitation systems. They've never had water and sanitation served to that community. And in this February visit, the temperature was -70 Fahrenheit. That was the ambient temperature. It was so cold that the fuel tanks that filled the machines, I mean, if you could even get a machine to start in that temperature was one thing. But the fuel machine, the gas containers that they had were frozen. And so when I came back in August of the same year, it was 102. So one, how do you engineer for this temperature variance? And we're still experiencing this in the same community. They are getting finally, and the planning is starting. The design will start in 2025. Water and sanitation as American citizens. The inequities are extreme because we aren't even at the same baseline when I have conversations with other Americans. And that is important because when you talk about any other inequity, the economic space or the engineering space or the migration space, these people do not want to move because they are on the lands of their ancestors. And their culture and their value system is to steward that land and keep that environment healthy. If we don't keep that environment healthy, we don't get provided the natural food from nature. How many of you have gone berry picking every fall for your entire life? How many of you fish for your salmon every single summer and store it and use it all year long? How many of you know that our cultures use every part of the salmon, including the vertebrae for jewelry? So this no waste value system has a lot to share with the rest of the world. Because when you're disconnected from nature in that aspect, there is a psychological and a physical well-being that is hard to explain in even a Western health context. And so I work as the Director of Climate Initiatives for the Alaska Native Tribal Health Consortium, and we are the statewide tribal health network. So we serve all our tribes and any other American Indian or Alaska Native that lives in Alaska. And when we look at that environmental impact through a tribal health lens, it goes beyond just what Western context silos things. So here we are talking about science and research. We talk about human impact, but we don't talk about human psychological and mental and behavioral health, right? We know that people across the globe have moved for as long as, we've been able to track it. But what we don't understand is what it does to us as human beings when we displace people who are so interconnected with the planet itself. We have a very reactive and recovery response system in the United States when it comes to climate impacts. We wait for disasters to happen and then we respond. Those processes need to change. The perspective needs to change. And this is the space where I think every single person in this room and listening online could help. Not only do we need the correct data, we need it from the places that tell us the story faster than anywhere else. We can't just keep studying temperatures in highly populated areas. If the cause is in the Arctic because there's a swing in that environmental system, that's the Earth system itself. So we have trends that we see. We have extreme flooding, extreme erosion, and extreme temperature rise, both ambient and in our waterways. That causes sea ice decrease, which causes sea level rise, which causes, depending on temperatures, as the temperature rises, this system is reacting to all these things happening. And so when you have a typhoon that hopscotches over the Aleutian chain in Alaska and propels into the western coast, which happened just a couple of years ago, and washes away indigenous fish camps that contain all their food resources for the year. There is no system in place currently in the US to respond to that. One, those fish camps were considered recreational because the people who make those decisions and create the policy are here in DC and they don't understand that life system, that worldview. Those processes are changing. We've recently at the consortium released the unmet needs report for Alaska Native villages that are environmentally threatened. That report calls out these processes and these challenges and inequities that are across the system currently. It also offers recommendations on how to respond. And that to me is important because this is where the science and research world needs to consider what can happen. So Alaska Native populations have been studied and studied and studied to the point where, you know, in some cases, the Inuit of the North that have stewarded the circumpolar North since the beginning of time were displayed in museums across Europe. People displayed as animals. So we have to recognize and acknowledge this history in order to learn and grow and be better human beings. Because really, when we look at the discussion of climate change and human migration, this is about saving humanity. It's not about one area on this planet, because the ripple effect of what happens in the Arctic and Antarctica, but the Arctic is populated, so you have history there. Antarctica only has science and only as long as science has been there. So if you look at my family and you're looking at 10,000 years in the same geographic spot in the north, modern science in Antarctica is what, 200, not even 200 years old. So you're looking at a sliver in time. So we have to take it into the context that it is in order to start to understand. So I would say that probably the most impactful thing would be to plant the seeds of curiosity in you, so that you understand that the person who's telling the most impactful oral history or story is going to be able to help connect those sectors and cross-pollinate different siloed systems quicker than anyone else. When we talk about economic, just the economic environments, we, in Alaska are considered all below the poverty level. So there's no economic drivers. Alaska itself has only less than maybe 3% private ownership. So it is governed by other either federal or state or corporate interest. And so when you think about that, when you talk about the economics and then you meld it with everything else, you can't even include us in your conversation because we're in that white zone, right? It's out of sight, out of mind. And so I'll leave you with just the seeds of hope that when I'm in these small communities and I listen to the elders and they tell me their stories, we don't have a word for story. It's really our oral history. They inspire me to make sure that we understand that they have been there for thousands of years, and they have knowledge, intimate knowledge of ice systems. And those ice systems are a trigger for the rest of the ecological systems that happen across, because that's what changes the water levels, the temperatures, the weather cycles. So,
Thank you very much, Jackie. A very powerful intervention. You know, it's not just about getting data right. It's not just a scientific exercise. You know, the real lives are at stake, and you know, particularly from what the kind of statement that you made, it's the kind of statement that I had time and again from the island states. You know, that take such a huge effort to come to these meetings to say what it is that they are suffering. You know, in terms of the climate impact and so on. So we have now a few minutes for questions. There are some questions already that are online. But before I go there, I just want to give those in the room an opportunity to raise any question that you might have. If you could kindly make it brief and then identify yourself, that would be very helpful. Alex.
Thank you so much, Jackie, for that wonderful presentation at the end. Very meaningful. I was thinking about the policy aspect and what policymakers want to know. And in some subsequent work, Laurie, to the groundswell, working with the Global Center for Climate Mobility, we have actually done a much better job of collecting data from people on the ground. And the vast majority don't actually want to move anywhere. They want to stay put. And so this, you know, the voluntary immobility is something that we need to look at and pay attention to. And how to facilitate that, I think, is one of the big, or the $64,000 questions right now, is how do you actually make it possible for people to thrive in place where they want to be and where they're rooted in community. And I think, you know, in this light, sometimes we also have to educate decision makers because they may not be as alert to some of the nuances of migration theory or other things that suggest that, you know, just pouring more money into communities is not necessarily the solution, or providing more money or putting more money in the pockets of individuals, though that can be a solution. And I think some of those experimentations around, you know, giving people money directly rather than this huge development, you know, aid interventions and a lot of experts that are paid out of that is actually really worth experimenting with and seeing how far that could go. But we also know that a good portion of people, given the opportunity, will move, at least younger people, because they see greater opportunities outside. So this is one of the tensions I see is, you know, there is some hope, I think, in the area of adaptation and food systems and making food systems more resilient. I know Diego and others in the room have thought a lot about this. And maybe that's one area also where policy can make a difference and enable people to stay rooted where they are if they want to do that.
Thank you. Jackie, please take a note of the question. I'm going to take some more questions so we can then go back to answering them at once. Who else? Yeah.
Okay, great talks, everyone. I was trying to actually connect the different talks in my mind.
You want to say who you are?
Yeah, sorry, I'm Pierre Gentin, Columbia University, and directing a center on AI and climate change. I'm actually, yeah, those were great talks, and I was trying to connect them in my mind in a sense that, you know, when we think about migrations and relocation, there's a sense of time scale, right? And Laurie actually alluded to that. And I'm wondering, how could you connect potentially those, like, for instance, thinking, as Jackie mentioned, about adaptation, right? It takes a long time, but the changes we are witnessing now are just way faster than they've ever been and ever witnessed, you know? So there's a lot that can be learned from past history and past, you know, like stories, and a lot of that potentially might not be in writing. But I wonder, like, how do you see that moving as changes are just so fast, right? And another connection is we are witnessing the very same thing for biodiversity, right? There's so much pressure and so much pace in terms of the changes. So very curious to hear your thoughts.
I have a few questions online as well. I'm going to just read them out. The first question is to Laurie. Does the US Census have questions about migration in their survey? Do they ask, why are you migrating? A question to Justin, the gaps in weather data that you identified are very interesting. Who are the people, groups, institutions working to close the data gap? And one question to Jackie from online. It is about the life systems that you mentioned. Do you think that studying the life system of humans will lead to know the exact impact of climate, which enable them to decide right solutions to prevent migration? So these 5 questions, if you could, anybody from here before I go back to the panelists? No? Good. All right. Who would like to go first?
Okay, so
Very quickly, because
yes.
we are short.
So Alex, it was really a comment, not a question, or you didn't have a specific question, really?
Well, it's partly both to you and Lori.
Okay,
So,
okay. Okay. Many do you want? Okay, so in the case of Alaska, our young population, some have migrated away, but you're talking about under, 50. When you have a population of 200, it's very hard to put on scale. So I'm going to pass that off to you, Lori. Pierre, and this interconnection, I always say Alaska is unique, and it is, but it's vitally important. I also work on the international space with all Inuit. And the Inuit of the circumpolar north have much knowledge to share. They're very well versed in Western ways, but they also have this traditional knowledge system that had science, had research, they were observation based, but they were intimate with the space itself and the actual environmental piece. So it's not separate. They weren't just watching it, they were interacting with it. So I think there is a lot to learn there. And then the online question for the yeah, I really do think there's a lot to learn here. Having different worldviews doesn't mean we can't sit in the same space and strategize on how to be good human beings and save the planet that we all love, right? Yeah.
Thank you, Jackie, and thanks, Alex. 3 quick things. Alex's contribution or comment on younger people are more likely to move, and you too, Jackie, it suggests another level of complexity, right, in projecting migration. You have to know the age distribution of the population that you're trying to understand, right? If the population is younger, you're going to probably project more migration. So just another layer of complexity. The second one, I love thinking about the specificities of context, and it relates to my comment about understanding when the maze can no longer handle drought or temperature. It's clear from Jackie's comment, what matters if we're trying to understand migration and well-being in the Arctic are measures of whatever temperature threshold ice systems start to shift in beyond a threshold, that can no longer be sustained. When are the salmon impacted in terms of water temperature, right? So thinking about the specificities of context and understanding the mechanisms through which these environmental change might fuel well-being, and in some cases, migration is just so critically important. And the last one, yes, the U.S. Census collects information on migration. The decennial census asks if you've lived someplace different 5 years ago. There's an American Community Survey now that is not a census where they talk to a sample of U.S. residents every year, and they ask a 1 year ago question. But no, there's no information on why people move. So that motivation for movement is critically important. And I'll tell you, sorry, one last thing. A lot of times when people will say they move for economic reasons, well, those economic reasons might have underlying climate reasons, right? So oftentimes when you hear economics, you have to think, well, what underlies that? The salmon aren't running, or the jobs aren't available. So thank you.
All right, I'll be quick. I'm sensing a sense of urgency up here. So very, very briefly on Pierre's point, modeling, I think about this from a modeling perspective. Modeling beyond human experience is what we're doing. We're extrapolating beyond the support of our data. And people, unlike the climate system, are not deterministic, and that is a challenge. The data poverty, in terms of that's being an issue area, I think data poverty on the geophysical side, a lack of climate data in places experiencing climate change first, is more problematic than a lack of data on the social side. And that is owing to the mechanics of how we model these things, right? And so if you're thinking about it from an empirical modeling framework, if you have uncertainty in your independent variable, that is mechanically much more costly from a statistical perspective than in your dependent variable. And there are lots of people working to resolve that. You know, including the data generators themselves for climate data. We are trying to articulate the scope of those costs right now, and hopefully that it kind of engenders some greater investment in data collection to include better use of oral histories and other histories. Ed Hawkins in the UK has been doing a wonderful job going back into creating climate records and actually turning them into degraded data, and those types of activities in communities around the world is incredibly valuable.
Right. Thank you for the panelists, and thanks to all of you for being here and for those online. I have learned a lot, and I just want to end on one note that Laurie had mentioned in particular. You know, whatever causes that people might say that prompted them to migrate, you know, when you dig deep into it, you know, we get to the climate impact. I mean, that is true, not just of what's happening here in the United States, but across the world. And in many of the intra-regional conflicts, etc., you know, we see this as the core issue. And I didn't quite get around to grasping the increase in home runs, but I shall in due course. But there are impacts, you know, that cut across various things that we do in the society because of what's happening to the climate system. Please join me in thanking our keynote speakers with a round of applause. And thank you again for your attention.
The next session, hello everyone, my name is Elizabeth Fussell. I go by Beth, I'm at Brown University. We're gonna just dive right into the next session in which all of our panelists are online. So I'm gonna stand up here right now, I guess, but it's a little bit hard to see, for me to see the panelists, so I'm going to return to my seat after getting this started. So this session is called Mechanisms and Pathways for Modeling the Impacts of Catastrophic Events on Human Migration. It's a twin of the next panel, which is also focused on mechanisms and pathways, but where the attention is on chronic and slow onset events. I think the speakers will blend these two different kinds of drivers. And so what we hope to take away from this session is a better understanding of these mechanisms and pathways, which of course are part of the kind of interconnected social environmental systems that we're focusing on here at this meeting. So let's begin with our first speaker, Giuliano Di Baldessari from Uppsala University.
Hi, everyone. It's a pleasure to be part of this workshop. I really much enjoyed the presentation so far, and I'm now going to share my screen for my presentation. I'm assuming you can see the screen, and that this presentation, I will focus on extreme events, as it was mentioned, and in particular to hydrological extremes, floods and droughts, and their interaction with human society, with a focus on human mobility. And to contribute to the discussion today, which is looking towards the modeling of human migration in the context of Earth system science, I will focus on the complexity of these interactions and the feedback mechanism between hydrological, climatic, and social processes. First of all, just some introduction with some of the aspects that were already discussed by previous speakers. The first point is that the research in this field shows that climate-related mobility is very complex, also because it's difficult to differentiate between different drivers, but it very rarely involves crossing the border. And when we speak about migration, it's often within national borders. I will provide more details about that. Another aspect is that we try to differentiate between different patterns of migration, depending on the level of agency. And we can have displacement. This was already discussed before, when we have involuntary migration, when the place is made not habitable, which could be, the aftermath of the Katrina storm leading to flooding of New Orleans, so the displacement of a large population. But we can also have voluntary migration with different types of agency, and also, as it was mentioned, across different scales. But here again, if we look into the proportion, most of it we see it, which is local, international type of migration. And when it comes to low agencies, also we should consider organized relocation that we see coming as an emerging aspect in the field of sea level rise. One dimension that was also partly discussed is that some groups may want or not want to move, but very often most vulnerable groups have no choice. They are unable to move. This diagram, which is very simple, if not simplistic, comes from an old report from the IPCC, but I think it well communicates another aspect related to climate-related migration, which is the one of trapped population. So if we simplify and we look into well-being growing from low to high, this tends to be related increasing ability to move, but decreasing vulnerability. So what we see is that the groups, the social groups that are most vulnerable to the impacts of climate change are often also unable to move. As a result, the empirical research, especially in the social sciences, shows that normally when we speak about migration in relation to extreme events, such as, for instance, intense flooding, this is often consists of short-term, local and or rural to urban migration. Here is an example. This is a study of about 10 years ago in Bangladesh, where we see that at the time of flooding, we have a large evacuation. And then part of the migration is temporary, then seasonal, and only a small part of it becomes permanent, and it is primarily internal in Bangladesh towards the urban environment. We see similar type of dynamics when it comes to the response to drought. So when it comes to type of research we have been doing in this field, we have been looking at the relationship between climate-related events, especially extreme events or catastrophic events, as we define here in the workshop, and changes in the spatial distribution of human settlements. And to this end, we have been using different type of analysis, surveys with the local population. But when looking at it globally, we use different proxies for the distribution of human population. One of them are satellite nighttime lights. And these are used as a way to capture the way in which human settlements change over time. And in the animation here, we can see in the case of the Limpopo River in Mozambique, how night lights change in correspondence to the river, and how this allows us to see how the center of mass of that human settlement and its distance from the river changes in time. And an outcome in this study that we published, well, now already 5 years ago, was that we could find a signal of increasing distance from the river, which was in different countries, which was related to the normalized flood fatalities. So countries that experience most flood fatalities were also the ones in which the distance from the river has increased the most. And what was interesting is also that such a tendency, which could be seen as an aggregated outcome of different adaptation activities, tends to reduce when we have higher level of flood protection. If we think here on the extreme right hand side, the Netherlands. So with higher level of flood protection, the increasing flood fatalities do not lead to increasing average distance from the river. And we interpret this as some kind of levee effect or safe development paradox. So when structural protection is in place, rather than new human settlements being more far from the river, we tend to rebuild the structure in place. And we also see that when high level of structural protection are in place, this tends to be associated also with higher level of urbanization of flood-prone areas. So this comes with also interpreting mobility as adaptation. And in a very recent study that we published only 1 month ago, so doing some publicity here, we have further explored this role of water infrastructure in mediating the link between floods, droughts, and human mobility. And in this case, this refers to agro-pastoralist communities, water dependent. And what we can see is that with the occurrence of drought, we often see the different organizations trying to help coping with drought through increasing water supply. And this can increase water availability and help coping with drought conditions. However, we found that without effective governance, this tends to reduce mobility, especially for pastoralist communities that strongly rely on that. And this hinder the resilience of pastoralists to climate change and drought. Another aspect, that the last one that I would like to touch today, since we speak about mechanisms for the modeling of the impacts of catastrophic events, are the feedback mechanism. So when we look at the link between climate change or climate-related extremes and human migration, we should not look at it only one way. As often we have very strong feedback mechanisms. In this recent study, we have, for instance, analyzed how dams, water supply, and population have changed in space and time in the US, and we found chicken and eggs problems. In particular, here we can see how the center of dams have moved towards the west in the US over time, and the same type of path was followed by the population. So we could do an analysis. I'm not going to give the details here, but essentially the water availability and also is both. It is a driver of growing population and water demand, as well as a response. So by on the one hand, the water infrastructure is built to cope with growing population, to meet increasing water demands. But on the other hand, the presence of dams and increasing water supply itself is a driver of growing and water demands, which has led to unsustainable water consumption, for instance, in the southwest region. This feedback mechanism does show that the distribution of population and also human mobility is not only a response to, but also a driver of climate-related risk. For example, some years ago, we did some study looking at increasing flood fatalities in Africa. Here we can see this dramatic increase. And we found that the increase was primarily driven by increasing population in African floodplain. So we have more people living in flood-prone areas, and on average, the distance to the river has reduced. And this can also be interpreted as a response to drought. So on the one hand, this human mobility has increased flood risk, but it could also be a response to drought conditions, which has made settlements close to river more favorable, all the other things being equal. Serena Ceola will give a talk about this recent study, which relates the occurrence of drought and human mobility in Africa. So to conclude, in this talk, I was touching on a few points related to the mechanism that we need to better understand for modeling the interplay of hydroclimatic risk and human mobility. These results come out of interdisciplinary research, and they clearly shows the uncertainty and complexity of the problem at hand. So the challenge of modeling these processes. The lessons learned, especially if we want to build simple models, is that human mobility mostly consists of temporary, local, and rural to urban mobility. And there is a major role played by water infrastructure in either enhancing or alleviating human migration. And I showed examples of levees and dams and the feedback mechanism. And lastly, the importance of considering human mobility both as a response and driver of catastrophic events and climate-related risk. Thank you.
Thank you. So we'll move on to our next presenter, Nina Lamb at Louisiana State University. Are you there, Nina?
Yes, I'm here. Okay, let me share the screen. Would you be able to see my screen?
Yes.
Oh, okay. So I wanted to bring the concept of climate change, human migrations to the resilience field, the community resilience, vulnerability field. And so when I look at what we're going to talk about, I just want to make two preambles. First of all, I feel that human migration away from a place means that the place is not resilient. And then long-term resilience is sustainability. So that's how I link human migration with disaster resilience or climate resilience. And I think this related to the work that I have been trying to do is that the very first fundamental first step is that what do we mean by community resilience or disaster resilience? And I make a preamble is that knowledge of disaster resilience begins with its measurement. And it turns out that is very difficult. We in the community resilience, disaster resilience, vulnerability, and risk in that field, there's a lot of different ways to measure resilience. So I'm going to just select 3 of the projects that I complete and try to see how the resilience is related to human migration. So I will talk about business return after Katrina. So it's not human migration, but it's business migration, whether they migrate or whether it comes back. And secondly, I'm going to talk about just very briefly about the work that I try to do. And I myself developed, and my team developed the model called the RIM model, Resilience Inference Measurement Model. And then I will also briefly mention the last one, which is the and household surveys of in the Mississippi Delta region. So so we all know that Katrina happened in 2005, and what I did is that with the support of from NSF and also interdisciplinary project, I work with economists, basically trying to look at what are the factors affecting business return after Katrina during this a time period that is very uncertain. So I thought I would just briefly, come up with. Sorry about all this wording, but basically I want to just go through quickly about the result, and I think I hope the findings add to the content, to the content of human migrations. So so what we did is that, okay, we find out from multiple rounds of survey, we look at how business return over a time, a short time. And obviously, in the case of Katrina and New Orleans, critical infrastructure protection is are the main point, like levee protections. So utilities and telecom communications. And so the reason why I mentioned that is that, these are the factors that may impact human migration away from a place that has endured lots of climate events. So and then the other findings that we come up with is that during the time, it's about 60% of the business find that, if they have an emergency plan that can help them to restore the infrastructure, will definitely increase their abilities to return. And one other finding is that that every time after a catastrophic event, it follows with some increase in crime, and also the lack of social infrastructure like education, health services. So so in order to improve the social resilience, these are some of the results that we would look at. So what are the implications of the findings? Well, we talk about that, after from the findings, the findings underscore the need to have public policy emergency plan. And then at that time, we, sorry about that. At that time, we're encouraging, the conclusion I make at that time is that we're encouraging business to go into the insurance program. And I think later on, I would also show it to you, how insurance would impact human migration too. So, and then we find out that, a small amount of recovery aid given to small business would have the biggest benefit. So it's we call it the nonlinear event, but also the nonlinear response is that the greatest effect would be in the first 6 to 9 months after the event. So I wanted to, and given that research as the background, later on working on the RIM model. This is the RIM model. And then the major point that I wanted to look at is to see whether we can have a good measurement of the communities. It could be counties, it could be zip code, and trying to see, is there any way that we can find out what are the capacity, what's the social and environmental factors that can make a community resilience. In other words, not losing populations in this case. So this is the model that I work on for quite some time. But the thing is that once, if I can be able to not only measure the resilience, but also identify what are the social and environmental capacity that make them resilient, then I can utilize those factors to look at the dynamics, which I don't have time to talk about. But when I look at the dynamics, we come up with another project that is looking at, for example, as a case study, the Mississippi River Delta, the New Orleans area, and to look at how this region, as an example of coupled natural human system. And so that's how, you know, the research evolved. So we look at the coupled natural human system, and then later on, I work with another group. It's also an interdisciplinary group to look at what is the household survey. You know, so let me show the other one. So this is the resilience inference measurement model, and I wanted to point this, not necessarily the detail of it, but the model has 3 elements. One is the hazard threat, and the linkage between hazard threat and damage is the vulnerability, and then the damage between recovery is the adaptability. So and these are the data, these are the real data that we really, in my model, I really need to have in order to come up with the final step, which is to come up with the step that I can find out what are the social capacity, environmental capacity to affect the resilience. So not only these 3 elements, I forgot to mention this one, is the natural human resilience indicators. I'm not going to describe very detailed about this model, but I just want to show clearly how to quantify this concept, the hazard threat. And this is really related to the Earth system sciences. That do we know the frequency or intensity of natural hazard? We know it in the past, but do we know it in the future? And also not only in the future, but in where? You know, is it more heat in the Midwest, or, you know, in different countries, or less heat, more rainfall, less rainfall? So these are the data that really would be useful in order to find out what are the capacity and relationship. I want to show that this is another study that is extending the measurement from the RIM model to a dynamic resilience analysis using a Bayesian network. And this is my former PhD student working on it. So my RIM model was able to extract key factors, and from the key factors, we try to model what are the population change in the lower Mississippi River Delta, the region that I just shown. So we find out, you know, these are the different environmental factors affecting here. You know, it's not direct; it could be a linkage. You know, so it's a Bayesian network to show how it could impact population change. In other words, it's based on this network, is that, you know, there could be some decision-making implication. In other words, if we wanted to increase the populations, and we probably have to increase the employment rate, or decrease the flood zones, and so on and so forth. And I wanted to also show that based on this, the previous study, we engage in a trying to look at a more system dynamic model, and what makes people move, and will the region be sustainable? And again, this our criteria of sustainability in this case is population change. So we divide the study area into grids, and then using a bunch of other techniques to try to calibrate the model. And I like for example, there's certain governance equations that we can, do it in a time series way. And eventually we come up with some sort of relationship between the utility meaning the resilient function that we derive, and then the populations and so on and so forth. We come up with, we generate some, we do the simulation, and obviously, I mean, it's kind of expect that, the area in closer to New Orleans area will not be able to sustain in next 50 years. So and we also come up with some hypothetical tipping point and mitigations. Again, we are limited when we try to do the work in modeling the projection and modeling the couple the natural human factors. We find that data is not very good. Okay, so and I think, sorry about the other diagram, and I want to show one last project that we recently have conduct, which is the household survey. And of course, the household survey is in the context of working with another group of Earth system science, landscape, ecosystem, and another group. But just briefly, we conduct a telephone survey of this region it's a telephone survey, very traditional, 1,1125 residents, and trying to see what are the consideration. It's not actual movement, but what are the consideration to move, and with this, just a very simple. I mean, I have more detail for that, but for example, we find out like even in this region, the 22% consider moving, compared with the actual migrations. Average, the national one is 11%. And then there's more than a quarter of people survey has already experienced flooding by Katrina and Rita. And then, this 15% has experienced the 2016 Louisiana flood. And that's a very serious one. But it's we call it no name flood. It's just no storm, but it's continuous raining. So anyways, but this is another interesting finding that among those who were flooded in 2016, 56% have no insurance. But we asked, why you did not have insurance, and they said that they are not required. So we are not sure whether it is true or not. But anyway, so this is some kind of finding. But also, as a geographer, or we interest in the spatial. In other words, is where are the area that would really wanted to consider moving away from the place that they have. So we, based on the survey, we come up with a decision model, and the paper is published, have been published, and we find out that flooding is not the only driving factor of migration consideration, not actual migration yet, migration decision considerations on a vulnerable coast, but economics is actually come out first if you want them to compare the two. So I just want to emphasize that, well, we talk about the local interpretation. I think I'm going to show you this. I don't know whether you remember, there's a movie long ago, not that long, 2012, Beast of the Southern Wild. And at that time, that's an interesting movie, and I watched that. And the LSU asked faculty in this LSU faculty to make some comment. And this was a comment before my survey. And I mentioned that, relocating communities to safer place is always a better solution, right? But relocation is not just relocation. We must come with having some economic opportunities available at the new locations. So that's one of the challenge that I put it in, the challenge number one. And I think this was on the news in 2016. The Louisiana tribe officially becomes America's first climate refugees, and people don't like the term refugee, but that was the term that was used. And this is the tribe location, and this is the southern part, coastal Louisiana. And then basically the Native American tribe has lost about 98% of the land. I mean, they have to move. I mean, even though there's some culture linkage and all this, but it's just no land. So in this case, it's really beyond the tipping point. And I think for this tribe, there was the government federal have put in, I think, $45 million for the moving away from the area. And then the challenge number two is that where do we move? And someone have already mentioned that. And I have also done another study, and my postdoc have done that, is that we did a study of the whole US, the whole United States, and look at the population change and the flood risk. And we find out that, a lot of people moving inland, but then not really aware of moving away from the coast doesn't mean that you're safe from inland flooding. So the challenge number two is that, we always want the migration too. Yes, to the economic area, good area, but also is the area also enduring certain kind of risk.
Nina.
So that's challenge number two. Sorry.
Nina,
Yeah.
excuse me, we have two more presentations. Can you try to wrap it up?
Yes. So I think the last point that I want to mention that this is the flood insurance just recently come out with the last June. Flood insurance to rise 122% on average in Louisiana. That's the part that really drive people away. And the fear is that the region would not have the middle class group because they cannot afford the insurance. It would be just the poor and the rich for the second home or something like that. So so I wanted to make sure. Well, I have two new projects that would do something like that. But I just want to show the takeaway message. Yes, I just want to make sure that my point is that issues of climate change and human migration must consider broader context of resilience. And still, from my point of view, still, what is the best way to measure community resilience? What makes a community resilient to climate change? What is the adaptive function? Can we say a resilience-ready community? And of course, my previous has shown that climate change-induced migration needs to be addressed as a coupled natural human system. And obviously, when we try to do that, of course, there are many of you have mentioned the data complexity and tools. So the main question from whatever the resilience community here is that what will risk look like in 25 years? So where are the areas that has higher heat, higher flood, or other threat? And the study also I want to also emphasize the flood risk is not only a problem of the coastal regions, inland flooding is also a problem. And then what makes people willing to consider moving? Economics is still the number one, but not necessarily the only one. So then the question is that top-down government efforts to do the coastal restoration like the place like Louisiana we have to really consider all this. Where are we going to? And why are we restoring land that nobody would want to live in? And I think the last thing is that the most effective thing is the insurance crisis. It's not only in Louisiana, but California and Florida. So then the last point that I want to make is that tipping point is not a point, it's a slow transition. So we are in this transition. So thank you for listening. I'm so sorry for the time.
Thank you, Nina. And our next speaker is Serena Seola from the University of Bologna.
Yes, hi, good morning, everyone. Thanks a lot for this invitation. It's a great pleasure being here. So let me share my screen and hope you can see now the presentation. And let me start the presentation now. So I'm talking about climate extremes, changes in human settlement patterns, and my talk will focus on droughts, and particularly in Africa. The reason why I'm talking about droughts, so that the focus of this session is on the mechanisms and pathways for modeling the impact of catastrophic events on human migration. So we can focus on floods, tsunamis, sea level rise, droughts, and I would like to specifically focus on droughts because droughts are one of the most devastating hydrologic extremes, and also climate change is playing a key role in increasing the likelihood and severity of impacts associated to drought events at the global scale. Quite interestingly, the World Meteorological Organization analyzed data from 1970s to 2019, and despite droughts represent only the 7% of natural disasters, the 34% of fatalities are associated to droughts. So these are extremely important for the losses, either economic, but also human losses associated therein. Then focusing on droughts and droughts in Africa, these have become more intense, more frequent, and also even more widespread over the past 50 years. Then, so one aspect is focusing on drought. The other aspect is that we are interested in focusing on human migration and mobility. And here I reported a map that was recently published at the end of last year that shows basically how the spatial distribution of the world's urban population, and in particular the migration. And what is visible from this map is that about half of the world's urban population is living in areas where the migration accelerated urban population growth. And as also mentioned before by Lori, but also by Giuliano, short distance mobility seems to be the most prevalent form of migration. And also what we need to acknowledge is that both climate change and specifically hydrologic extremes, such as floods, but also droughts, are impacting the risk of this migration, either temporary or permanent. Related to the short distance mobility, we must acknowledge that, as also cited before and mentioned before, is that climate-induced migration is more common within national borders, and also that disaster displacements are 3 times larger than displacements associated to conflicts and violence. So based on this, I'm now recalling the diagram that was also shown before by Lori, published by Black in 2011, where if we want to focus on human mobility from droughts, we should consider different drivers, different factors spanning from political, social, demographic, economic, and environmental. But what I'm focusing on in this presentation is simply the relationship between human mobility from droughts and the environmental factors that could drive this human mobility. So the research question of this presentation, and also the paper that we recently published in Earth's Future, is that are drought occurrences, other factors being equal, so because we did not have enough data to consider all these factors, are drought occurrences associated with a larger human mobility towards river networks or towards urban areas? So we decided to focus on Africa, as I mentioned at the beginning of my presentation, and we tried to provide for the first time some data about the interplay between the occurrence of droughts and changes in human settlements, because past work was unable to identify such interplay because data were not sufficiently available. So in this work, we explore this relationship. We perform country-based analysis. Our study period spans from 1992 to 2013, and within this year, we extract annual drought occurrences, and we consider two different indicators, other SPI 12, so the standardized precipitation and evapotranspiration index, aggregated at 12 months time scale. So you see the countries with a light yellow shade, but also we consider EMDAT, so the emergency database that I'm going to describe in the next slide. Then we also extracted human settlement patterns, and in particular changes in human settlement patterns, either considering relative urban population from World Bank or considering the human distance for rivers. And these two plots shows the temporal behavior for the country. So regarding the identification of drought occurrence, we perform this identification for each country and for each year. So we classify a generic year as a drought year if the country-based average value within every year is of the SPI 12 is smaller or equal than -1, which is the classical threshold used in hydrological sciences. But also we list that specific country and that specific year as a drought year if we have some data on the number of people affected that is available from the EMDAT database. So for each country, we built a table which looks like this one. So to classify if the year is a drought or no drought year, according to both indicators. Regarding the changes in human settlement patterns, as Giuliano mentioned before, we defined the human distance to rivers as a spatially explicit measure of the human presence in relation to the position of the river network. To do this, we estimate this variable for each country and each year, and we couple nighttime lights with the geographical position of the river network. So you can see the sketch here. So we have the distance from the river network, and then the different colors refer to the different nocturnal luminosities, which are considered as a proxy of human presence and activity. And so this human distance to rivers is a weighted average distance of people with respect to the river network. Then to further consolidate the analysis, also we consider relative urban population as derived from the World Bank database. Regarding the methods and the analysis we performed, so we have different information for each country, so time varying human settlement patterns. And for each country, we compute changes in human settlement patterns as the difference between two adjacent years. So either considering both the antecedent and also the subsequent year. And given this year Y, we then ask ourselves, if this year I is classified as a drought year, then we created basically two groups of years for each country. Years labeled as drought years and years labeled as non-drought years. And for each of these two groups, we computed median values of these changes in human settlement patterns. We computed these median values because we wanted to test our research hypothesis, meaning that we hypothesized that during droughts, we should see a reduced human distance to rivers. So people tend to move closer to the river network to get more water resources. But also during droughts, people tend to increase, to move towards urban areas because they have to differentiate their personal income. This analysis was also performed by comparing drought years with the whole study period without distinguishing between drought and non-drought years. So now let me show some results. In this slide, you see two different maps. Okay, the two maps refers to the two different drought indicators as introduced before. So the maps on the left refers to the SPI 12 drought records. So we colored countries that experience droughts according to these specific drought indicators, and the same applies on the right-hand side, where countries are colored according to the occurrence of droughts related to the EMDAT records. Then on the top of each plot, on the top of each country, you can see circles, colored circles. And basically these circles represent our research hypothesis. So you see that from both maps that we found an increased human displacement towards rivers, as highlighted with these dark purple circles, or towards urban centers, highlighted with these small light purple circles. And we identify this by comparing adjacent years and by comparing median values between drought and non-drought years. And these results are consistent for both drought indicators, but also for considering either the antecedent and the subsequent year. The results are summarizing this chart that basically shows the relative occurrence of this drought-induced variation in human settlement patterns. And you can see from these purple boxes that the majority of African countries are experiencing this increasing presence of human settlements, either close to rivers, dark purple, either close to urban areas, light purple, or both close to rivers and urban areas. And these values, this percentage range between 70 and 81%. Then what's next? So what about future climate dynamics, but also future human dynamics? So according to climate change scenarios and also to the IPCC, if there is a 3 degrees increment in the temperature, it is likely to see a 3 to 20-fold increase in droughts for most of Africa. But then if we look at the urban patterns and the urban expansion, there are publications that highlighted that the urban extent in drylands will increase significantly by 300%, 700%, and also the population living in drylands by 2050 will double. So this means that these rapidly growing cities in Africa will be risk hotspots for climate change, but also for human displacement associated to climate change. How can we tackle this? How can we also, from a mathematical viewpoint, analyze this issue? So we can, for instance, better explore this issue, considering also future scenarios, by applying some spatially explicitly modeling framework. This is an example of a paper currently under review that basically is able to forecast and reproduce the urban expansion according to geomorphing and hydroclimatic drivers. And so through this spatially explicit framework, it is possible to describe changes in human settlement patterns, but it can also potentially be employed for human adaptation strategies to worsening climatic, worsening socioeconomic living conditions. So it is possible to perform this spatially explicit analysis. So let me provide you some take-home messages. So in this presentation, I wanted to show you an analysis that was based on different data sets, including also satellite-based data. And it aimed to explore the interplay between changes in human settlement patterns and the occurrence of droughts in Africa in a given time period from 1990 to 2013. I must acknowledge that we deliberately not consider any other factors despite drought. So we are well aware that human mobility patterns are controlled by multiple factors. They also depend on the local context. And so the analysis we performed was at the continental country scale level. But what we observed from data is that we found drought-inducing incentives towards closer to rivers or closer to urban areas. And the majority of African countries experienced this, so between 70 and 81%. This is extremely important because, as was also shown before by Giuliano, so if there is an increased population in floodplain areas that is taking place during droughts, so during droughts people are moving closer to the river network, then if a flood is occurring afterwards, you can imagine the fatalities, the losses that can occur and could be associated to these catastrophic events. I would like to thank my colleagues, so Giuliano Di Baldassare and Joanna Mard from Uppsala University, and Enrico Bertuzzo and Giulia Grandi from the University of Venice, Ca' Foscari. This is the bibliography, and then I would like to thank you for your attention. Thanks.
Thank you, Serena. And in this, the rather longer session where we have 4 presenters, last but not least is Elizabeth Marino. And Elizabeth, are you there?
Yes, I'm here. Hold on just a second. I was trying to fix the video screen. Okay, can everybody see my slides?
Yes. Thank you.
Okay, great. Okay, hi everybody. Thanks so much for having me. Thank you, Beth, for facilitating this panel. My name is Elizabeth Marino. I work at Oregon State University, and today I'm going to be talking about research that mostly came out of a book a group of colleagues and I recently published called People or Property, Legal Contradictions, Climate Resettlement, and the View from Shifting Ground. This book is primarily based on case studies that in the US, and it's largely about how conceptions of property law, and regulations that affect property, such as zoning regulations, shape the way that risk is constructed in landscape and the way that relocations, both planned and unplanned, happen in the wake of flooding disasters. These are those meso-level drivers that was talked about earlier. These are disasters, these flooding disasters that we tracked typically have a climate signal, meaning that they're driven by storms that are statistically likely to be larger, more frequent, or more intense because of climate change. And so we can think about them as examples of climate change driven migration or relocation. This is the cover of our book. I totally love it. It's a picture that was taken by a friend and colleague, Dennis Davis. Dennis lives in Shishmaref, Alaska. Shishmaref is an Inupiat Alaska Native community that is considering relocating off of their barrier sand island home because of repetitive flooding linked to climate change. But it's a picture he took of a house that's owned by a family member of another colleague of ours, Chantal Carmadel, in Ile-de-Jean-Charles, Louisiana, which has already been mentioned today. So Ile-de-Jean-Charles is a community that has largely relocated off the island because of repetitive flooding, and both places have been considered first examples of climate-related migration. Both Chantal and Dennis were colleagues in the research project that produced this book, and more importantly, they have a photograph exhibit, and I'm going to show pictures throughout this presentation of that exhibit, which you can find online here. Okay, so I'm going to talk about modeling climate relocation soon, but I wanted to share with you that the first section of the photo exhibit by Chantal and Dennis is maybe surprising to some of you, called Beauty. And it's a powerful example to me that it's important to start conversations about climate change with remembering what it is we want to protect and not just what it is that we're afraid of. Dennis and Chantal do this really well. Here's an example of one of the pictures that's in that category of photos called Beauty. So I started working on climate change-driven migration as an anthropologist in 2007 when I was conducting dissertation research at the University of Alaska Fairbanks. As I think we've talked about using that black model a few times, 20 years ago, the literature on human migration was mostly divorced from environmental cause. So people moved to oversimplify jobs, education, housing, family, and urban life, and away from conflict, persecution, disaster, rural areas, violence in the state or in the home, or boredom. And despite the archaeological record being full of instances globally of environmentally driven permanent migration, contemporary migrations were not really understood as such. In Alaska, as permafrost was thawing and newly erodible shorelines were losing up to 20 feet of land in a single night, the perspective from the ground was that storms had changed and that in some cases, migration seemed like the most reasonable adaptation option to this new ecological norm. 20 years ago, these extreme flooding events in Alaska were mostly invisible to the public, but the tides, pun intended, have certainly changed. As the climate crisis becomes more widespread within public consciousness, the places and people actively planning resettlements linked to storms became emblematic of climate change impacts. The complete invisibility that plagued Alaska's rural West Coast and Louisiana's lower bayou communities has, in some important ways, come to an end, and that can be a good thing. But it also has problems. So Beth Fussell and I were authors on the National Climate Assessment, and in the media training that we had before the release of the report, the communication expert told us that we had to give a why, what, and a why it matters in response to questions from the media. And the what in her example was that sea levels would rise, and the why it mattered, as is so common that it's almost become a trope, was that it would displace millions of people. And I don't know what other social scientists felt like about this example, but it made me feel tired to think of a bevy of natural scientists using displacement as a justification for why their work was important. Being recorded. Sorry. This new visibility around climate migration created challenges, and a primary one that the growing attention has grossly oversimplified climate as a driver of migration. Remember that 20 years ago, the climate was not thought of as a driver of migration hardly at all. And in this map I'm showing, it suggests that 700,000 people migrating into Mexico City by 2025 are climate migrants, which if you consider the history of understanding migration drivers is really just a bananas estimate compared to how those same migrants would have been characterized in 2005. And this map is random. It's the second image that came up when I typed climate migration into Google. But I really think it's important to think about the ubiquity of this message that climate drives migration. More importantly, the people that we have worked with who are planning relocations in Ile-de-Jean-Charles and Shusmaref, Alaska, understand that these climate hazards are mediated and made manifest by social calculus and political decision-making. For example, in Ile-de-Jean-Charles in Louisiana, over a century of levee and dam building and oil and gas extraction created the susceptibility to land subsidence and erosion that then in turn has led to the deterioration of Ile-de-Jean-Charles and the land around it when it's met with bigger storms. On top of that, in 2002, the Army Corps of Engineers decided to exclude Ile-de-Jean-Charles from the Morganza to the Gulf levee system. That also created conditions that made the island even more susceptible to storms. Disinvestment by the state and federal governments in protecting the road to and from the island made it difficult for families with school kids or people with off-island jobs or medical needs to remain living on the island due to getting stuck when water inundated the road. That in turn had the consequence that the fewer the population and houses inhabited on the island meant that the island was less likely to meet cost-benefit calculations for hazard mitigation. So under these socio-political circumstances, we would argue that it's disingenuous and inaccurate to blame risk and exposure simply on the rising temperature and global sea levels. There's also growing concern among our research team that this public attention to climate-driven migration has turned from ignoring relocation, like I was talking about 20 years ago in Alaska, to treating it as it's inevitable. This narrative glorifies relocation or retreat as the only viable option in response to climate change and sea level rise, regardless of community desires. And we know in Harris County in Texas right now, neighborhoods that had previously been offered voluntary buyouts and didn't take them are now being forced to move through a mandatory buyout mechanism, which is this idea that about mandating that people move because of environmental shift is fairly new, and it is something that we need to watch very closely as researchers. Now, if storms render places uninhabitable, as our media consultant would like us to believe, then mandatory buyouts might make sense. But social scientists know that that is not an accurate model of risk. Risk is mediated instead by things like hazard mitigation infrastructure, levees, seawalls, or home elevation. Access to hazard mitigation is in turn mediated by a family's capacity to carry insurance. I was glad that that came up in a previous talk. It's mitigated by being highly ranked in competitive grants or being seen as a neighborhood worthy of investing in by local governments. During the writing of our book, a colleague of ours sort of joked that he was going to start a Twitter feed called Highest and Best Use, because so much financial allocation in the US is modeled on supporting people or industries that are engaged in what is considered highest and best use of a property. But of course, highest and best use are measured by development, economic activity, and real estate value, which are often protected by the state no matter where it's located, while rural homes are left to their own devices, or spoken of as if, and this is a phrase that we heard all over the place, that they never should have been there in the first place. Of course, that's not what we say about oil and gas development off the coast. So these complex socio-political and economic conditions, zoning, hazard mitigation, carrying insurance, et cetera, are conditions that are also often mediated by race and class. And these are the complex drivers of social migration at least as much as wind and waves. So modeling a more holistic picture of risk is more critical to me than modeling the likelihood that risk of flooding will drive mobility. Forced relocations have historically been a striking predictor of social disarticulation and lowered socioeconomic status. The history of development-induced migrations is clear that forcing people to relocate is frequently bad for them in the long run. And that gives people like me pause when we think about the mandatory buyouts that are rolling out in Houston or around Houston right now. And we should also remember that policy is developing so quickly in this space that scientists are really, I think, the need for us to move quickly and then be careful model what we say in absence of the full picture of migration is really important because these broader kind of culturally driven narratives are really triggering policy outcomes that we need to at least be aware are interrelated to how we are having this conversations about climate change as scientists. So flooding is not the only risk that people are exposed to. Again, Beth Fussell and Melissa Shutton created this graphic for the National Climate Assessment. And I think this is a really interesting way to think about climate migration that includes some of these more both longer term and also just meso-level sociopolitical inputs. The point here is that relocation can be adaptive or maladaptive depending on the sociopolitical and economic circumstances that relocating communities end up being in following relocation. Critical to this discussion is not just when and whether people move, for how long and in what direction, but what their lives are like once the move occurs and whether they are better or worse off, and then what drives that risk distribution or that risk burden after the relocation. And this is the model I'm interested in. I would call it maybe the legal landscape of risk. As one example, how properties are mapped, invested in, zoned, and used have an impact on the risk burden that people have before or after they encounter some kind of environmental hazard that might make them think about relocation. As an example, the Alaska Native Claims Settlement Act in some cases created huge swaths of state and federally owned land that surround communities now looking to relocate. And it takes an act of Congress to change those conditions. So what does that mean in the context of communities that need land for relocation? Another example is how legal landscapes shape the opportunities and limitations of mobility. A case study from our book is that voluntary buyouts, which is the policy most regularly used in the US for planned relocations, are framed by the takings clause in the Fifth Amendment of the Constitution that says governments can't seize property without just compensation. But in the courts, just compensation has been defined not by a legal argument really, but by convenience as fair market value. Now, if you have a cabin on the Hudson River or a cabin on the Kuskokwim River, fair market value is extremely different, even if the price of replacing that cabin is the same. So these kinds of legal landscapes significantly shape the opportunities for adaptation. So I'm interested in modeling what risks and opportunities does the regulatory landscape create for people who inhabit these places, what industrial activities and other development projects have historically and contemporarily contributed to vulnerabilities along a coastline, and then given these pre-existent social articulations of risk exposure, then we can ask, where will bigger storms have an impact? And I think this is a much different model than a social vulnerability index. So can we model policy pathways? What is the pre and post overall risk burden of a community or household that takes a buyout instead of elevating their home? Are there policy pathways that are underexplored and so unmapped? Our author team was interested in policy pathways that exist in other countries. For example, the Scottish right to buy. How would that apply in the US when we think about options for relocating communities? We also wondered if and how holding a land in trust could benefit communities who wanted to relocate as a group. These are multifaceted exposures. These multifaceted exposures to risk are complex and difficult to measure, but I think it is possible. And I do think that there is data paucity and that it is difficult to put the legal landscape into these other drivers of migration, or I haven't seen it done sufficiently yet. But we know that climate change is the perfect excuse for complex climate modeling. So in Alaska, there was a climate research project that modeled a vertical slice of the Arctic from the microbiome of a tundra environment up through the upper atmosphere, trying to understand the multidimensional dynamic interactions of a changing climate. And I would like to see a similarly complex and similarly funded model that takes the dynamic social nature of risk into consideration with a specific focus on how laws, policies, norms, and regulatory structures funnel risk into and away from certain areas. And among other outcomes, perhaps we could offer, through this kind of large-scale legal landscape modeling, some analysis on what it means to have highest and best use. So thank you very much.
Thanks, Beth. And thank you also for plugging the National Climate Assessment, the 5th National Climate Assessment chapter that we were both that you led on social systems and justice. I think that as we focus on systems generally, whether they're Earth systems or social systems, we all might benefit from taking a look at that chapter and thinking about how social scientists are entering this conversation with a systems perspective to think about how these meso and macro level factors impinge on and sometimes limit people's ability to make migration decisions. And so, so thank you for bringing that in. We have a few questions. We have little time because we have run a little bit over. I want to first ask if there are any questions in the room, and then I will turn to the 2 questions that have been asked online. Yeah.
Hi, I'm Christina Kennett-Brophy from Mystic Seaport Museum, and just to contextualize, I'm leading an international council of maritime museums looking at maritime refugees, and we have about 40 museums involved in the project from around the world, and we're just sort of launching the project right now. I'm actually going to a meeting after this about it with my council. So I had a question because all the modeling, this is obviously much more of a global look that we're doing. But when we look at maritime refugees, and again, we're even trying to determine the definition of that term, how do you find information in your work through these models to determine whether or not these sort of urgent escapes, which are often fraught with real danger, obviously, death, fear of the ocean, having never gone to sea, it's very urgent, you're not planning on going back, it is permanent, it's not within national boundaries, like how related they might be to climate change. Because as Lori and others pointed out in the first session, this is obviously a very complex issue and it's not one thing typically, but a lot of it might stem from some sort of climate change that impacts other drivers to leave. So just sort of a broad question to all of you guys as you're looking at these models, how do you determine that decision-making process for some of these people trying to flee from climate change and other factors?
Great. I'll ask the panelists to hold their responses until we have all the questions on the table, and then maybe some of them will overlap. Any other questions in the room? Samai.
Thanks for your presentations. I'm Samai Dash at UC Santa Barbara. My question is about the nightlight data sets and whether these data sets are representative enough for settlements that are not official and they don't actually have official electricity to be popping up on these data sets. So if you could comment on that.
Great. Oh, Lori?
Just in the spirit of this workshop, I'm curious if any of the speakers, how you've integrated or would want to integrate Earth systems science into what it is you do when we're thinking about how we might come together. Is there a space within your work?
Hi, I'm Kristen Whitney, a postdoc fellow at NASA Goddard. I'm curious too about something that has struck me is there was a mention that we should start by reminding ourselves of what we want to protect. There's been a lot of mention of hope from stories from the tribal leaders. And I just want to ask, how can we as scientists and researchers trying to develop this Earth system modeling, how can we incorporate sort of a community-driven vision that includes sort of a storytelling element of the future that we would like to have, what we want to protect. And there was a mention of how this migration story as the only viable option is problematic. So how can we have a more holistic vision of viable options? And yeah, what are some methods to do that? given some of the topics of data scarcity. How do we have a data on that sort of visioning process?
Okay, thank you. That's a lot on the table. I'm just going to add two questions that came from the audience, the online audience. One has to do with policies, and I think gets to the point of the sort of feedback effects between policy and migration and water infrastructure, where the question is, if policies have led to migration in the United States, particularly the westward expansion over a long period of history, and then they've also driven the need for developing new water infrastructure to satisfy the needs of the growing population, how can policy then come back into the equation and alter those that legacy of past policy? Another question is whether panelists can comment on community resilience impacts that result from who is migrating, and by who the question might be having to do with the level of skill of migrants that would contribute to, say, a brain drain or remittances back to the community. And then how can those sorts of characteristics of the dynamics of migration and migrants be integrated into Earth systems models? I think that question is one that some of the panelists themselves were asking, and so we might not have an answer for it, but it'd be interesting if any of you want to comment on that further. Another question for Dr. Ciola is about, you mentioned migration shifting people from being exposed to droughts to being exposed to floods. Have you looked at whether there's any whiplash in migration, which, what are the effects of moving back and forth between these two different kinds of hazardous areas? All right, that's a lot of questions on the table. I would encourage panelists to pick one and focus on that briefly, and we will have time in the next panel to continue this conversation.
I can answer the one that how is the research integrate with the Earth system science? And I mentioned that, well, in my model, but it's not just my model, the 3 elements. And one of the major elements that we don't know what is the risk, the threat in the next 25 years, or even a good estimate of the natural threat. In other words, it's like if we talk about right now in the United States, we have FEMA to look at the flood zone, but we don't have information on where the heat zone or heat stress zone, and what is the model that we can, is that a good climate model to show where are the areas? So I think this is, to me, this is the major part. And also it's not just the heat, the threat, but also within the context of damage and critical infrastructure. That's the information that is really, really hard to find. So I'm going to just stop here and let other people to respond to other questions.
Maybe I can reply to the questions related to the use of nighttime lights and also the analysis of droughts and floods. So regarding nighttime lights, so if they're representative of informal settlements, so we are well aware that informal settlements cannot be correctly represented, but we are considering time series. So if we are assuming an error or an underestimation, this should be consistent throughout the whole study period. And then also we performed an intercalibration before analyzing nighttime lights, and also we computed normalized values for comparing results from different countries. Then regarding the moving back and forth associated to floods and droughts, so I did not personally inspect this issue, but there are several studies that focus on this. And it relates, for instance, to the study that Giuliano presented before related to the increase in human distance associated to floods. But then, yes, so there are studies currently focusing on this.
Yes, so then I can probably briefly comment on the interplay between policy, migration, and infrastructure, the question, and how to break the legacy. So the idea is that, for instance, the example I presented related to the United States, it is an analysis of this interplay without saying whether this led to something good or something bad. But just to show that what it did was to lead to extremely high level of water consumptions in some areas, such as the southwest of the United States, where naturally there won't be much water. And we know that then when drought occurs, consequences can be catastrophic or lead to groundwater exploitation. What we can do as scientists is to expose this legacy. So to show how this interplay between hydroclimatic and socioeconomic processes, so to study, as also Nina presented before, to study this issue as a coupled human-natural system can lead to a legacy risk, to conditions which may not be desirable. So that, I think, is the primary role of us as scientists.
I can speak to the question about I think it was how do we understand the climate modeling that's going on and see that it could be potentially problematic to think about relocation as inevitable. And so one of the things that I think comes, one of the pieces of information that we talk about a lot is whether or not people want to move. This has come up in a couple of slides today, this idea that there are people that are either stuck because they don't have the financial resources to move, or people that choose to stay in a location because of long-term attachment to place. And then we often compare those to whether or not or to how relocation plays into those kind of individual and family level decisions that are made. And one of the things that I think is missing from those kinds of analyses is it's often, relocation is often presented as a unilateral decision. Like it's a decision that it might be complex, but it's a decision that's made once, and it's a decision that that it's a decision that's made once, and that it is it will overall reduce risk. And I think one of the things that we see in the case studies that we look at as an anthropologist, that's the scale that I do analysis on, is that people are often not answering the question, would you relocate? They're answering the question, would you rather consider the livelihood and family relationships that you're in now, social relationships, or would you rather have them disrupted and move towards a different livelihood or a different social arrangement? And with that, people are answering that question in different ways. So this model that came out in the NCA about thinking about relocation as adaptive or maladaptive based on the risk burden that people have following a relocation, or whether or not they're able to articulate just a coherent sociocultural livelihood after relocation, is a different way to approach that question. So I think that we would find that under many conditions, communities are willing to relocate, so long as they are guaranteed that their lifestyle and livelihood will stay the same or improve following that relocation. And we have good data from lots of different kinds of relocation drivers that say that that's not always true, that it's risky to relocate. It's especially risky to be forced in, or to feel forced into relocation. So I think that these, so I feel like that I think that thinking through what will happen as there's dramatic shifts in coastlines is really important. But I think we can reframe the question to consider, how will these potentially inevitable relocations maintain coherent livelihoods and coherent sociocultural narratives for people that are engaged in that relocation? And that answers the other question about how we can think about kind of hope for the future, or working towards the future that we want to see. And it can also it can also take the burden off of just this individual family-based decision to relocate or not as kind of a one up or one down type of decision, and instead think about what people are moving towards or what people are deciding to stay for.
Great. Thank you, everybody. And I think we've only just begun our conversation. I look forward to continuing interrogating these questions and all the topics that have been raised in this morning's panels. It is time for lunch. So thank you, panelists who are not going to be able to enjoy the informal discussion that we are going to be having, but we really appreciate your participation here. Thank you.
Start the session two's event right now. So just
recording in progress.
Excellent. We're now being recorded. So welcome everyone to session two. Today, this portion of the event is talking about the mechanisms and pathways for modeling the impacts of chronic and slow onset events on human migration. As Beth mentioned earlier, this is a set of two conversations. So the first being more on catastrophic events, and this session being more on protracted long-term types of impacts. I'm Shana McLean. I direct NASA's disasters program at within NASA's Earth Sciences Division. And we've got three incredible speakers with us today. One is in person. This is Kevin Anchikaitis from University of Arizona. And then hopefully online, we have Christina Cataneo from the European Institute of Economics and Environment, as well as Cascade Tucholsky from Montana State University. So with the intent of staying on time, I'm going to turn things over now to Kevin. Thank you.
Great. Thank you, Shana, for organizing this session, and my thanks to all the organizers as well as the National Academies staff for bringing us all together. It's a little fuzzy. There it is. Okay. So you'll see another name that appears up here besides mine. That's Talia Anderson. And as I was putting these slides together, I realized that I wanted Talia's name to appear here because she's just been doing all this cool stuff that I wanted to share with you. So she is a PhD candidate in my lab. She will defend in a couple of weeks. I have her last chapter on my computer right now. And she's really done some fantastic work. So keep an eye out for her. And she's been doing this under the auspice of this NSF grant here from the Human, was it Tom? Human Environment and Geographical Sciences. All right, good. I have a suspicion that Cascade might show this. This is from a paper that he and Alex and others published very recently, last couple of weeks. But I'm just going to use it as a sort of a structure to sort of place what I'm going to speak about over the next couple of minutes within this larger question of one of the ways that we might expect that climatic change or extreme events could work its way into human environment, socio-ecological systems, is through the food system and through agriculture. And so this is a figure from this paper. This sort of shows the progression and interactions between climate events, climate extremes, climate change, the food system linked to socioeconomic aspects of this larger system, and then the decision to migrate and mitigating factors in that. So I'm going to just sort of be in these two spaces mostly, and I suspect Cascade will take up some of the other parts of the system. So I want to talk first about sort of the climate change aspect, and as we start to think about the sort of slow onset or chronic conditions that could interact with migration, what are some of the complicating factors in modeling that? And then I want to sort of further complicate it by thinking how these events, how these trends or changes might be perceived, and how these perceptions might or might not lead to action, particularly by smallhold farmers. And then how this, potentially also one more complication makes our models somewhat difficult to establish. Yeah.
The audience cannot see the slides or hear anything. These are things I'm seeing online. So.
No. Yeah.
Are we good now? Okay, thank you.
Yeah, no worries. No, thanks for letting me know. So those are the two aspects that I will focus on. I'm going to take you here to where we've been working now for over a decade, and specifically where Talia has been conducting her dissertation research in Central America in what's known as sort of the dry corridor, which has various definitions. But if you sort of look at the dark orange there, an area of lower rainfall, very high levels of food insecurity, frequently formally declared famines, and an area of interest for potential climate change impacts. And one of the reasons that this is an area that we've focused on is this is one of the sort of hotspots, if you will, for expected future drying. So I'm showing you here is from the IPCC, the most recent assessment report. This is from their atlas, which allows you to really nicely call on the various modeling results, different time periods, different scenarios. And so this is for a relatively high-end scenario of emissions, SSP3, so not the highest, but still relatively high compared to what we think is perhaps the most realistic. And this is showing you changes in precipitation by the end of this century, so sort of 75 years hence. The browns and yellows that you see are areas of drying, and these are in percent changes in precipitation. So some of those regions, if you sort of look at Nicaragua, parts of Honduras, and the Yucatan, some of those numbers are in the sort of 25 to 30% change in decline in precipitation. And where you don't see any cross-hatching, so where you can clearly see the colors, these general circulation models, these Earth system models that we're using to project the future agree. The trend is significant in terms of a statistical significance, a statistical test applied to these trends in precipitation, and that the models agree on the sign of this trend. So this is about as good and clear as it gets. Perhaps some places in the Mediterranean and others show similar distinct expectations for the future. But same scenario, but let's only run the models forward to 2040. Now what you see is, perhaps first of order, not surprisingly, that the magnitude of the decline in precipitation is smaller, right? So perhaps you can see the sort of slight yellow there behind the crosshatching. But more importantly, the crosshatching indicates that the trend in precipitation change in these models is not significant compared to the magnitude of internal variability. What that means is, while there might be an underlying trend that you can sort of detect there in the light yellow, the normal sort of internal natural variability of the climate system continues to dominate over the trend. And there's some really nice work that's been done on this, Clara Desser at NCAR, amongst others, showing that this is a result that is fairly consistent out through the middle of this century, that many places where we expect a climate signal to emerge, a climate change signal to emerge, it doesn't do so even for the next sort of 30 or 40 years. So the implication for that is that we're still going to have to deal, even with these sort of chronic onset, long-term changes, in this case in precipitation, which would be expected to affect the agriculture and food systems, we're still going to have to deal with internal variability. And if we sort of look and zoom into this area, this is a paper that Talia published about 4 or 5 years ago now, looking at wet season rainfall trends across this region. A similar sort of, ambiguous picture emerges. So there are places of in fact, significant wetting over this period, 1981 to 2019. So Pacific coast of Guatemala, for instance. There are some areas of drying, but for the most part, any of these trends are not significant. And so again, even leaving aside the models, observations would suggest that we're still in a period where trends have yet to emerge, and we're still going to have to be dealing with the impacts of internal normal climate variability. So even as we enter an era that we expect to be associated with these long-term trends and these sort of more chronic onset conditions, we still have to wrestle with these aspects of the current climate system. Justin already touched on this much nicer than me, but even if I can put up this map, right, what went into being able to make this data set, and I think Chris Funk is going to talk tomorrow, what goes into making data sets like this and others are those station data. And as Justin showed, those station data are not equally distributed in space. They're not fully represented in time. And so this is from an older paper by Phil Jones for their climate research unit network, which was one of the maps that Justin showed. And what they're doing is showing stations that have precipitation data. So they're in this data set. So the circles are data sets that are station data sets that are in here. And they're filled if they have more than 50% of the data in this sort of 60-year period between 1951 and 2012. And so, once again, the sort of unequal distribution of observations will jump out at you. And if you sort of go over to where we've been studying here, so looking at Guatemala, Honduras, El Salvador, into Nicaragua, there's vanishingly few stations that make it into this data set. It doesn't mean they don't exist. And in some cases, these data sets have come and gone through time, often in response to internal politics, civil war. But we have a very unequal distribution of climate observations over this area. Even though we do have these data sets, I think it's important also to realize that it's not necessarily clear which one we should use. So this is just for a single location. This is Huehuetenango in the Western Highlands of Guatemala. And this is where we've been doing some paleoclimate work in my lab. But if you look here, this black line is what we have been able to acquire from the weather station. This is mean annual precipitation from Huehuetenango. The black line is the weather station. And all these other lines in the different colors are different data products. So we have that climate research unit in blue here, the same one I was showing before. One of the ones you often see published on is GPCP, which is the only one that has a downward trend. And so if you were to do your analysis of rainfall at Huehuetenango using just GPCP, maybe you would say, the trend has emerged. On the other hand, GPCP, which has a lot more stations, is sort of flat to trending positive, and then reanalysis, which has the closest match, interestingly and somewhat surprisingly to me, is sort of flat while the station suggests a wetting trend. So this is to say that, again, even as we expect these sort of chronic conditions to be emerging over the next several decades here and in other parts of the world, our observations of those in many places, not just in Central America, but through large parts of the tropics and the global south, may not be up to the task. And even when we have these data, it may not be clear which one is right or most applicable, I guess, might be the way to put that. And again, natural variability is still really important. So this is from this really interesting book by Brent Metz about the Chortimaya in eastern Guatemala, and talking about sort of the long the fact that the Chortimaya have been long inhabitants of this region, have been through a lot of internal climate variability that we would classify as a drought and leading to food insecurity. So that just this one quote about oral histories and historical evidence for a 1915-1916 drought. This drought dried streams and springs, made farming impossible, drove many campesinos to eat banana roots and seek water, charity, and wages throughout the region. Seek water, charity, and wages throughout the region, right? Migration, internal migration in this case. So this is not to say that if we don't see the trends emerge, we don't have to worry about things like food security, or we don't have to worry or be concerned about migration. In fact, even as chronic conditions may be emerging over the next several decades, we still have to deal with the consequences of climate variability and extreme events today. And just to say that we've shown in our own paleoclimate work that if you sort of extend these records back using tree rings, that a similar picture emerges, which is that there are decade to decade changes in sort of the distribution of rainfall, but nothing that emerges beyond the range of those sort of last several hundred years. So this internal variability that may be affecting already migration and food security in the region is part of the climate history of this region. One thing that sort of has caught a lot of headlines regarding climate and migration in this region was sort of during the last administration, the previous presidential administration, migration, external migration from Guatemala, Honduras, El Salvador to the United States. There were a lot of headlines like this, a lot of headlines and very little data. So fifth straight year of Central American drought, helping drive climate migration. Climate change is the overlooked driver of Central American migration. And then I believe this was in the New Yorker, how climate change is fueling the US border crisis, right? So already saying, right, that climate change is working its way through this food system structure and through into livelihoods and already having an impact. One thing that emerges as an additional challenge that I hope the social scientists will take on board is the question about the sufficiency of climate models for studying things that we care about in the future. So when we went to start investigating this particular drought, Talia, again, we were sort of sitting talking about this and was like, well, what about using some of these ensemble climate models where they've run climate models for dozens and dozens of times? Justin has a very nice paper on this. As a tool for studying climate variability, internal variability, and the emergence of a climate change signal. And then roughly when we're having this conversation, this paper by Pascale et al. Came out, and in the supplemental material was this plot sort of altered now to protect the guilty. The climate model names are now obscured, so you don't know who the who's wrong in any particular interesting way. But showing that for Central American climatology, right? So just getting the sort of pattern of annual rainfall down. Things are better than they used to be. I think last time I looked at this, like no models could even get half of the sort of magnitude of the rainfall. That's still true for these models in blue. They tend to be too dry overall. One of these is too wet. And then this orange one doesn't even get the structure, this sort of dual structure that we know of as the midsummer drought here. So, you know, models are a very useful tool, but it's important to consider as we use them to project the future, not simply in terms of, say, temperature or even precipitation, but how those things then work their way through a model understanding of the food system and migration, what some of the potential limitations and uncertainties are. So Talia took a different approach. She did a statistical sort of emulation approach called an observational large ensemble. And one of the conclusions from her 2023 paper was that the 2015 to 2019 Central American drought that the media had sort of grasped on as causing migration from Central America to the US was indeed severe. So this is sort of percent of normal rainfall during that 5-year period. The black line is what we observed. And then the blue line are all of her possible simulations. So it was severe. There's no question there was a severe drought in 2015, 2019, even if we sort of have trouble measuring it. But it's not something that required climate change to occur. And so the emphasis here is not don't worry about climate change, but we need to think about how food systems and the downstream effects of those, including migration, are affected simply by what the climate system can do all on its own. Then I'll end with this, which is just to say that something else that we've been working on and Natalia has some forthcoming papers on are how people perceive changes in climate, right? So I've shown you measurements, I've showed you simulations, but actions on the ground, including sort of choices that people will make about livelihood or migration, are often influenced by perceptions. And so there's a number of sort of ways this appears in the literature. One is that if you perceive inaccurately that, say, the rainy season is coming later or earlier, or you know there's some other change that affects your livelihood, you could make decisions that are maladaptive in the end. And these examples in the citations are from everywhere from New Zealand to Eastern Africa. So this is not confined, this is a human condition, right? That our perceptions guide a lot of what we do. And our perceptions can lead to actions that could be maladaptive. It's not to say correct perceptions lead to adaptive decisions that are good. But on the other hand, if we, right, as climate scientists or modelers or what have you, just say, well, we know what's happening, and we ignore people's perceptions of their own environment, their own knowledge of their own environment, then any kind of information or assistance that we might be hoping to render could also just be ignored, right? So why would people listen to us if we just say, well, we know what's best? So Talia deployed a 700 household survey in Guatemala, and it was sort of a massive undertaking. I'm just incredibly proud of the work she did and just kind of in awe of it, actually. But one of the things she looked at was farmers' perceptions of rainfall change over the last decade from these two communities, Chiquimula and Tornicapan. One thing is that while kind of everyone knew it was getting warmer, we've seen this in other surveys that are not ours, people didn't necessarily agree on whether it was raining more or less. And in fact, as I've shown you, it can be tough to say whether it's raining more or less over the last 10 years, given just a lack of data. So that's interesting, right? How do you sort of address different perceptions and sort of ambiguity in measured trends when sort of thinking about how do these things propagate into food security and potentially migration? But also, this was really interesting. Between the two communities, if you perceived that there were changes, no matter what sign you perceived, whether no change or it's different every year, or there's less rain or more rain, the two communities were vastly different in terms of whether people had then changed something about their agricultural practices. And Talia really dug into, the survey, and the clearest predictor of this difference between these two communities is off-farm income, right? So perceptions aside, in Chiquimula, where there's not as much available off-farm income, people made agricultural decisions to try and address what they perceived of as a change in climate. In Totonicapán, they may have perceived those same changes, but they had off-farm income and they were buffered by that off-farm income to not have to worry so much about food security directly from their own lands. They had other way to purchase food. So even perceptions are not going to necessarily guide actions. So I'll close with this then, that from sort of Talia's work and our ongoing work in this region, these large amplitude but natural variability regions of the tropics will continue, this natural variability will continue to be important in affecting people's livelihoods, even as models tell us in regions like Central America or the Mediterranean or elsewhere that we expect a long-term trend towards drying and the negative impacts on agriculture we would expect from that over the next 80 years. And this will really continue to be, in many ways, a dominant influence on agriculture and livelihoods and food security. But that even if trends start to emerge, and right now we can't say they have, perceptions of rainfall change are widely variable. But even those perceptions don't lead directly or deterministically to any particular action. They're mediated by a whole host of other things, many of which are sort of part of that diagram that I showed from Cascade's paper. So with that, I will, yep, that's the last one. Thanks very much, appreciate it.
Thank you very much, Kevin. That was excellent. I mean, I think it's this conversations that we're trying to have are about, you know, where there are opportunities and where there are challenges. And I think what we're starting to really see very clearly is just the extent of complexity that exists between models, perceptions, and then eventually decision-making and action. So with that, let's turn to our next speaker, Christina Catanea, who is online. Christina, are you with us?
Yes, I am online. Hi, everybody. I'm trying to share my screen. I hope you see it. And okay, so hello, everybody. My name is Cristina Cattaneo, and I work at the CMCC Foundation and RFF CMCC European Institute on Economics and the Environment. I'm very happy to hear Kevin's presentation, because I think mine is going to complement a little bit some challenges and gap that scholars find when they want to analyze relationship between climate change, weather shocks, and migration. Because if you want to analyze this type of relationship, you need both good data on one side, which is climate related, but you also need good data on the other side, which is about migration. And so I will address different types of challenges that we face when we want to analyze the relationship related to historical relationship, but also related to what we expect about future migration flows. And I think the main gaps in this type of modeling are related to you know, very constraint on global migration data. There are some gaps in knowledge about the interplay between different types of adaptation strategies to climate shocks. We need a better understanding of what I call moderating factors, which end up creating some heterogeneous response. So we always tend to think about climatic shocks making people move, but we need to consider that there are many contexts and circumstances where people tend not to move because of, for example, lack of resources. But this is just one dimension, and we better understand what are other dimensions. And finally, as I mentioned, all these different gaps are then feeding into a major gap, which comes when we want to understand projections of future climate flows. Okay, so first point, I just want to give you an overlook of what used to be and are the main sources of migration data. And in this presentation, I will mainly consider international migration, which means a move of people from one country to the other. Okay, the main limitation of gathering migration data is that it's difficult to capture and measure it. And historically, the best way to measure migration was through censuses and registers of destination countries. So basically analyzing making a picture of the population in the destination countries and asking them their nationality or the place of birth. It was possible to collect information on stocks of people that come from some origin countries and that are settled in some destination countries. So the advantage of this procedure is that it allows a very large temporal coverage because, as you may understand, census happened since many years. So basically, despite being quite dispersed, because this type of measure provide typically decadal information, but at least they allow us to have a kind of global perspective of origin and destinations. The disadvantage of this type of approach is that they lack a wide geographical coverage. So for many years, we basically had access to information of stocks from, let's say, all origin countries, but towards only limited and typically OECD destinations. But as you may know, international migration relates many countries of the world. In particular, there are a lot of flows and stocks between South countries. And another type of disadvantage of this type of data is that they lack socio-demographic details of people moving. So typically, the maximum information available was the gender or the education, but many other dimensions, relevant socio-demographic dimensions, were completely absent. Alternative sources of data come from origin countries. And typically, this type of data source provide geolocalized information on place of origin, and they can also provide some socio-demographic characteristics of movers. But consider that this type of information that come from survey are normally intended to measure other types of dimensions. So typically, living standard measurement survey were designed to measure poverty, or there are also a lot of health surveys. So given that the purpose was not specifically on migration, it was, not many times it was quite hard also to get information of migration from this type of origin country sources. And some disadvantages are related to the lack of representativeness of the move. And then if we consider modeling migration from these specific countries, sometimes it's difficult to extract generalized messages and outcomes. And then another disadvantage is the limited temporal coverage. Now, there are new sources of data that are typically referred as big data or digitally traced data. So the advantage of these data source that typically come from social media, such as Facebook, Twitter, and basically what they do is they capture the location where users log in or information on location that are provided by users in their tags. Or also information from mobile phone call detail records that capture the call signals that are sent to different cell towers, or also remote sensing technologies such as satellite or aircraft-based sensors technologies such as drones. So the advantage of this type of sources is that they provide a very fine geographical detail because they are typically geolocalized. But as in some disadvantages, they lack socio-demographic details. So we know very well, basically we know nothing about who is actually moving. We just see whether there were moves from one place to the other. And then they typically consider a narrowly defined location, and they also provide just a limited time frame. Now, so these are the gaps that have to do with the data, so the way we measure migration. But then there are also gaps in the way we are able to model the link between climatic shocks and migration. Because as it was discussed previously, migration is only one of possible strategies for adapting to climate change. And sometimes migration is just the last resort solution. And why? Because in particular, if you consider international migration, it brings a lot of and high psychological costs that many times are higher than crop switching or other adaptation strategies like changing livestock species or changing occupation, or implement some agricultural innovations such as irrigation or also insurance. So sometimes in the literature, given that there are a variety of adaptation strategies, the fact that we observe migration is because we may think that all other adaptation strategies failed. So the question is whether we should consider migration as a failure to adapt rather than a true adaptation strategy to climatic shocks. And in the modeling arena, what I think is missing is a better understanding of the interplay between these different alternative adaptation strategies. So whenever there is a shock, what are the options that household individuals consider, and why migration is more or less likely to occur with respect to other strategies. And then connected to this point, there is also a way to model what I say is the heterogeneity. So in other words, there is a lack of understanding of the different dimensions so the different mediating factors. So for example, we all know that migration is costly, and often lack of resources can prevent migration. So even if people do have a high incentive to move, given that they are often the most vulnerable to the impact of climate change, they become the less able to move because they are those that have lower resources to invest in migration. And what we typically observed is our trapped population, and these trapped population are typically the most vulnerable population of a society, because they are the poorest, the least educated, or typically the woman. And there might be, so now I considered like a liquidity constraint as a possible a constraint factor, but there might be many other sources of immobility that we need to be studied. And this also has implication from gap number 2, which has to do with the modeling the interplay, because immobility could also be a choice. So we don't know whether people don't move because they lack resources, or instead because they do have alternative adaptations. But the point here is that we don't know still, or there is a lack of modeling of all these different dimensions that might or not prevent migration. And finally, I think what we actually need the most are projections of future climate-induced flows. But the problem is that there are still, despite there are a lot of studies that connect historically climatic shocks and migration, there is still a lot of uncertainty concerning the future climate-induced flows. So historically, there had been some attempt to provide numbers, but often this, or at least the original, the first attempt tend to measure the number of people at risk. But we know that being exposed to climate hazard does not necessarily imply that people decide to move, because as I just mentioned, there are alternative forms of adaptations. Then there are other, like more sophisticated ways to predict future climate-induced migration that exploit historical relationship. But typically, if they consider a short-term historical elasticities, it's hard to project far in the future what will be the number of people moving because of climatic shocks, because short-term responses are very different from long-term responses for a variety of reasons, because there is adaptation, maybe something that will occur in the future that was not available in the past, or maybe because the short-run responses rely on, for example, on selling assets, but this is just one option that is not affordable in the long run. So just to say that there is still a lot of, and then, sorry, to add on this point, there is still a lot of uncertainty on future climate models and also social economic scenarios. There have been, here I quote, two well-done attempts to project future migration. The World Bank groundswell report that only consider internal migration. And then there is another research from Missirian and Schlenker, where they actually exploit like historical relationship and provide future flows, but this is just a limited part of the story, because they consider only refugees and they consider only a unilateral context, meaning that they were not modeling bilateral flows, but only flows of refugees that has protection in specific destination countries. And just to conclude my presentations, I just want to summarize what are the implications for modeling climate, so future climate-induced migration due to the different gaps that I highlighted. First of all, there are implications that arise from the data availability, because if we want to have a good projections for the future, the data need to be trained on long historical data. And as if you remember, there are very few sources that go back in the past. So even the new and the novel data that are geolocalized, but they are just limited in their temporal coverage. And as a conclusion, there are very few sources that are long enough to allow us to generate sound projections. There are implications that arise from gap number two, and in particular, as long as we don't have a good knowledge of the interplay between alternative adaptation strategies, it's very hard to have good models of future migration. And finally, there are also implications related to the gap number three, and in particular, understanding what are these moderating factors that determine whether a person move or is trapped in immobility. And yes, so I'm at the end of my presentation. Thanks a lot for listening.
Thank you very much, Christina. Fascinating presentation. Let's move on now to our final presenter, Cascade Tucholska. As he's coming online, just a reminder to all of you, we will follow his presentation with the Q&A. So please do add any questions you have for those who are online into the chat, and we'll be sure to carry them, connect with them following the presentation. Cascade, over to you.
Thank you. Thank you so much for the opportunity to speak today. And a lot of what I'm going to cover has been said in different ways. So I'm going to really emphasize efforts to improve maybe not necessarily improve our understanding, but offer new ideas in the way in which we can understand how we define what is a long onset or chronic climate impact to a community, to hopefully connect back to the socio-ecological systems that may be related to climate migration mobility. So, oops, there we go. So this, I'm sure many online and in the room are well familiar with this diagram, but in graduate school, it really struck me because I grew up during the Arab Spring and reading headlines around the world about climate change, being a threat multiplier or a cause of the Arab Spring. And that was very much in the back of my mind before I started graduate school. And then I read this paper, like many of you have, that really simplistically breaks down the reasons people move are much more complex than any one given driver. And so any environmental exposure, for the most part, is always embedded in these social, political, demographic, and economic forces that, as we know, are multi-scale and reinforce one another. So in short, this complex system is very complex, and I always try to remind myself, and now my graduate students, to really not try to have any per se preconceived notions as to what might be driving a human action in these complex socio-ecological systems. And this point was recently reiterated in a different way, I think, by this paper in Science led by Radley Horton, that just emphasizes again that there's an inherent risk in climate determinism because it reduces human agency and it really reduces, I think, oversimplifies what's happening on the ground in any local community. And I live in Bozeman, Montana. I know a fair bit about Bozeman, Montana. I do global scale research, but at the end of the day, really culturally, my viewpoint is I can speak a lot about climate migration in Bozeman, Montana, and that's about it in terms of being really confident about kind of the cultural influences without doing really sustained on-the-ground research. And what this paper highlights is top-down modeling is really informative because it identifies hotspots, say for habitability decline or chronic or long tail onset events. But to really understand and make policy, make relevant and informed decision in terms of policy, you need to blend this top-down research with the local and social context. And this really, as is said throughout this workshop today, and I'm sure more will be said on this tomorrow, requires transdisciplinary and really cross-cultural collaborations to understand what we actually mean when we talk about climate migration. And so context is key. And I think top-down approaches do not per se capture qualitative economic, social, cultural, and political context. And then there's this, as has been said, there's a serious risk of ecological fallacy, whereby we observe the movement of people, often through secondary data, and then we associate it spatially with some sort of climate hazard or climate change event. And those two things are maybe correlated in space and time, but climate change is not per se the driver of the movement of people. And one thing that I think about, as I kind of already said, but I just really fear that we will over-attribute movement of people to climate change rather the social or political or cultural context that might actually be creating the underlying conditions whereby people don't feel safe or comfortable or are seeking new opportunity elsewhere. And so while the data set that I'm going to present in a few slides is really a top-down data set, I really emphasize to keep this in the back of your mind that as more bespoke data sets come online, it's really important to, again, work with transdisciplinary and cross-cultural teams to frame the context in any given location as to what may or may not be driving people out of location. And as Kevin already noted, this is a paper we recently published where we unpack one proposed hypothesis related to climate-induced migration called the agricultural pathway. And so in simple terms, the hypothesis is that climate change would impact agricultural systems and rural households livelihoods would be impacted, and then they would make a decision to migrate. And this is embedded again in the broader socio-political cultural systems, and these are multi-scale processes. And so with this, we wanted to outline the different components needed to really unpack, to tee up future research to unpack mechanisms that may or may not influence the agricultural pathway. And so I'm really going to focus on a data set we recently published that addresses the climate side of things and gets at both what Kevin and Justin talked about in terms of lack of data availability and a lack of understanding of natural climate variability irrespective of climate change. And so there really is a challenge in defining what a slow onset climate event is in a data sparse location. The example from Guatemala, I don't need to repeat what was said. It was really eloquent and well stated. And we need to, in any given research paradigm, you need to clearly define what is a slow onset event or a chronic event. And once we define that, we need to step back and really understand whether we are attributing correctly these sorts of events or climatic change to human or anthropogenic climate change. And then the next thing I've been pondering quite a bit is, again, how do we measure the impact from a climate change driven event on the decision to migrate? And so just kind of repeating again some things that have been said. So these figures are from two papers. I published one with Ben Zaitchik at Johns Hopkins University, where we just talked about the advantages of using Earth observation data to basically gap fill areas where we don't have station data. And very back of the envelope calculation, we estimate that 4 billion people on the planet live more than 25 kilometers away from a weather station with a reliable reporting record, and that's only back to the 1980s. And so that's the plot on the left. And if you look at the map of South Asia, the green areas are urban settlements. There's approximately 3,000 urban settlements in India. And in terms of publicly available weather data, there are 111 weather stations. So this, again, as has been said, creates a pretty big challenge for measuring what is a slow onset climate event in any given location, especially in really densely populated places on the planet. So if you think about the CMIT-6 model projections, the raw data from the CMIT outputs, the highest resolution they're available is 100 by 100 kilometers. And so when I think about this, I think about when I used to live in Southern California, and it was quite nice depending on where you live. And this is roughly to scale of what 100 by 100 kilometers looks like. And so those of you who have spent time, say, in Santa Monica, it's about 75 degrees Fahrenheit almost every day, pretty much always, and it's really pleasant. And as you move inland, I mean, you can have in the San Gabriel Mountains, 10 feet of snow can fall, and then you move farther inland and north, and you can have 115-degree weather, and that can be all within the same month. So you have huge spatial variability in local climate. And then when we want to think about a person, assuming you are lucky enough to have locational data about any individual, red dot is obviously not to scale. Where do you put that person on this map? Where do you put them in this grid cell to understand, future climate projections and the impacts on people? So if you take observational record here, I'm just pulling Era 5 data, say using a 25 by 25 kilometer grid cell. I mean, this is the spatial relationship we're trying to understand in terms of past observations and future projections, and you have a huge spatial dependency issue. So my colleague and good friend, Emily Williams, who's now at UC Merced, led this effort to create a new set of climate projections called the Climate Hazard Center CMIT-6 projections. And these are 5 by 5 kilometer climate outputs. And I'm not going to go into the details too much about how these projections were created to make sure we have enough time for questions. Our paper was, or Emily's paper, I should really say, was just published in Scientific Data, and I'm happy to share that with folks and discuss offline exactly how these data sets were built. But basically, we took the CMIT-6 projections and calculated the delta between the model projections and the model historical runs. and then applied that delta to high resolution climatology built by UC Santa Barbara Climate Hazard Center called CHIRTS, and then the analogous precipitation data set is CHIRPS. I'm sure many of you are familiar with that. And so you can take that delta and apply it to the observational record. And what we produce is basically, we ask the question is, what was the weather like from every day to 1983 to 2016? Or I should say, what would the weather be from 1983 to 2016 under a 2050 climate, say for SSP 245 or 545? And we produced several different climate products with this data set, but the emphasis here was on vapor pressure deficit, which is pretty useful for measuring hot, dry conditions or hot, dry extremes that are really relevant to agricultural productivity. And then an approximated shaded wet bulb globe temperature, which is relevant for human health and extreme heat impacts on human health and labor productivity. And so you can take these data sets and you can plot the daily maximum of the observational record versus projection. And this is a slide I put together for a different talk, to be honest. So it's from New York City, but I think it's pretty interesting because the CHC CMIT6 data is trend preserving. So you can ask questions like, what was the weather like in 2016 in Manhattan versus what that exact same summer would look like under SSP 245 and 585 out to 2050. And one thing that really stands out to me from this data set is because we only produced the data through 2050 so far, but those who are familiar with climate modeling community is like the climate projection, the different forcing pathways don't really diverge much until 2030, 2040, 2050. And so you see that even if we rapidly reduce greenhouse gas emissions today, a lot of the warming signal is already baked in. And this figure is using the preliminary data, and I have to double check if the final data, but you see that LaGuardia Station measured a heat index about of 111 degrees Fahrenheit. Our observations show about 112. And then under climate projections, we see that same heat wave in 2016 could produce conditions of up to a heat index value of over 120 degrees Fahrenheit, which I think is fairly concerning. So to conclude, I think trend preserving higher resolution climate projections like the ones we've built, and we are not the only group who are working on downscaling climate projections. And so I think it's really important for any analytical product to use multiple data sets to try to build some confident or confidence bound sensitivity or uncertainty with it. And then I think slow onset events, once they're defined, need to be linked to actual impacts to humans and linked to a decision to migrate. And then on the ground impacts and mobility people need to be substantiated by the experience of the people who have decided to move. And I take very seriously that there is the decision to move and the perception of the climate around them versus climate being a proximate driver. But I think in the narrative, especially in the media, as has been said, conveying the complexity of the human decision to migrate it's really paramount that's conveyed in the media and to policymakers, so we can really understand how climate change may be creating slow and onset events that drive people to leave their homes. So with that, I'll stop. I thank you for your time, and I guess we're on to questions.
Excellent presentation. Thank you very much, Cascade. So we're into the Q&A portion. Luckily, we've got ample time for questions, which is exciting. So maybe we've got a couple online, but maybe I'll do what we've done historically so far and turn to first the people in the room. But maybe also similar to what we've done, we'll take a few questions, field several of them in clusters so that we can get to everybody. Any questions in the room? Yeah, Diego.
Thank you so much. Thank you for the panelists. It's more common than a question, but I'm bringing to the table, we have not mentioned gaps in theories as well, and I think that's very important. I've noticed in recent research, and because I've heard it from many panelists in the previous sessions as well, there's new migration out of of Guatemala in certain regions of the highlands that doesn't require any finance at all. And you might remind me of that theory, the inverted N, where two people that is under poverty wouldn't necessarily migrate, and those that are too rich wouldn't necessarily migrate. We're starting to see a different approach there where coyotes, right, which now they're financing agents of these people that previously was not able to do it. It's a business. And so they're starting to do this. But I think we also need to bring into the conversation the gaps in theories. So that's my comment.
Thank you very much. So along with that, I'll ask everyone if they have any comments on Diego's comment, but we also have a question about, I think it largely stemmed from your presentation, Kevin, about why Central America is a hotspot if the trends in rainfall are uncertain. And then I believe it was connected, well, this is probably broadly respondable by all. Very lucid and thoughtful presentation comments, Manasi Kumar. Could you talk a little bit more about immobility from being a vulnerable population, and what are the ways to address this within climate hazards and associated costs? So maybe, oh, sure, Amir.
So we learned a lot about gaps in data. For social science studies, what kind of spatial and temporal resolution do you think is needed in an ideal world, assuming that our models are fine and they do what they want, what we want them to do? What's the kind of ideal temporal and spatial resolution?
Okay, we're entering into a tricky, large number of questions. So why don't we pause here, let the three speakers address these, and then we'll come back to additional questions either on the room or online. Yes.
So I can address the hotspot question. We've now, as a climate science community, gone through many generations of computer climate models, general circulation and Earth system models. And one thing you look for is consistency across, say, emission scenarios, across generations of models. And so there are regions that stand out over all of that as consistently showing a decline in precipitation, whereas pretty much everywhere it gets warm, the patterns of change in precipitation and other hydrological variables are spatially and geographically more complex. But Central America is one of those places that has over decades of modeling shown it's going to be one of the places that we expect to have substantial declines in rainfall over both seasons, wet and dry season. And these signals emerge sort of always usually late in this century, so 80 years, 75 years hence. There's other regions. The Mediterranean is another region of very clear drying. There are a few others. So when I say sort of hotspot, I mean, whatever the uncertainties in our models, and they do exist, and particularly in sort of absolute values, right, millimeters of rainfall, the sign and the magnitude of declines in rainfall and precipitation in Central America and a few other places are so consistent that our eyes are really drawn to them. And particularly when vulnerable populations are involved, we have to think about those consequences.
Christina, Cascade, would you like to address any of the other questions? There's a comment on gaps in theories, the ideal spatial and temporal resolutions needed, and then also the question about immobility and vulnerable populations.
Yeah, if I can start regarding the immobility, yeah, it's a good point because as I addressed in my presentation, the most immobile people are the most vulnerable ones. But my suggestion would be to make immobility a choice, because as I said, migration is the last resort chances. So if we are able to address the climatic shocks, making people adapt through the different spectrum of actions, then we allow people to choose to stay rather than being trapped. And regarding the other questions, like what would be my ideal world in modeling the migration, so clearly, I'm asking a lot because, again, as I addressed in my presentation, if we believe in statistical models where we generate a causal relationship between shocks and migration responses, and then we want to employ this type of information to inform about future, what we need are data that go back in the past. That means that they are able to capture not just the short-run elasticities, but long-run elasticity. And then another dimension that ideally would be great to improve is the spatial resolution. Why? Because if you rely on country level information, then of course you need to somehow make proxies of the type of shock that a specific person faced. But clearly, if you consider a huge country, of course, there are a lot of differences in the shock that people are exposed to. But if you only have country level information, you need to kind of do some, this type of proxy. So what we typically do is to basically weight the different information on that come from weather stations or satellite data. So we tend to aggregate them by using some weights that typically are population weights, but still this is a limitation. So ideally, we would like to have not only geospatial climatic information, but also geospatial information of the origin of the people. Thank you.
I'll add one quick point, just so folks have time to ask more questions. But I think, I mean, tech companies, any data from Facebook, any data from cell phone, I mean, you have issues with digital divide there, but I mean, that's the most high resolution human mobility data I've ever seen. I don't know of any other data sets. The problem is that, it's fairly recent. But going forward, I think there's major privacy concerns with that. But in an idealized scenario, that's point location that pings a cell phone tower every few seconds. So that's promising. Of course, you don't have much backend data of who those people are on the social science side. And then in terms of theory, I have one point of just something that I don't have a good answer. And I've asked a lot of people this question in terms of sustaining rural livelihoods and climate adaptation. Often I see ag technology, especially Western mechanized industrial scale agriculture, proposed as a climate adaptation solution to keep people to help people become resilient, farming communities become resilient and keep them in agriculture. But if you look at the history of Europe and the United States, the more we mechanize and the more technology we brought in, the less labor demand there was for agriculture. So I don't know if that actually, in the long run, shores up resiliency for rural communities to adapt to climate change if the quote unquote motivation is to give people options so they don't have to decide to migrate, assuming it actually is a decision. I don't have a good answer for that, but I think that is in terms of like new labor economic theories or just going all the way back to like Frostow's theory of development, like we need to think through what that means in terms of teeing up capital to these communities if we're going to do that, whether we're one, that's beneficial for the two communities, what they want, and two, what that actually might do or not do.
Excellent, thank you. Let's turn back to questions in the room. Alex, Beth, and then, okay.
She actually invested in this workshop. Alex DeSherban, and thanks to the panelists, great panel. Christina, I was just going to mention a couple sources of data that you might consider or add to your list. One is the long-term demographic surveillance system that exists in some countries in Africa, for instance, and in other regions. I know that there have been some papers written on Niakar, for instance, which is one of the sites in Senegal. And, you can go back to the 60s and basically have some information about household composition change over time. It's not perfect, but you get a sense of whether youth are leaving or coming. the other big proponent of this kind of longitudinal research is Vali Kubi, who's really set up some really interesting, I'll call them sentinel sites, where she's gone back over several years to basically survey and understand what's going on in, say, Bangladesh. I think she's done some work in the Vietnam, in the Mekong, but I'm not certain of that. And I also know that there's a new sentinel being set up by IOM in Mexico. So there's these opportunities, even though it won't yield fruit for a number of years, to start collecting data over time. I do think one of the things that both Kevin, I guess, alluded to and Cascade points out, and it's come up before, is that these, we're looking at the past as prologue for the future, and there's real limitations to understanding how much we can really infer from past behavior when changes may be on the order of 50% declines in precipitation in places like Central America. And I think we have to look at that very seriously, and what kind of adaptation investments would be needed in order to make those places viable. Sorry, that was more of a long-winded comment than it was a question. I apologize.
I think we might end up having a lot of comments disguised as questions, which is what a conversation is, right? But thank you, everybody on the panel. I wanted to just, call out that all of you were talking about the agricultural pathway from climate to migration. And there's a lot of, potential unobserved variable bias, things that didn't go into the model that we should have considered. And one of the things as a demographer, I think about as potentially troubling some of the conclusions is that, the past century or 2 centuries there's been a long-term secular trend of urbanization. People are simply creating cities. And some of what you all are observing is maybe the forces that drive urbanization that may not be associated to the environment and climate at all. But and Cascade, you sort of mentioned, mechanization of agriculture being a potential driver, but also just the pull of the cities and the changing economy. And so one of the things I think and I'm just going to, as an aside, I agree with Alex that the past, we're treating the past as prologue, which may be shaky ground for prediction. But let's just, if we want to get the models of the past right, we do need to think about these other drivers of urbanization and how they fit into our model. I'm glad to see you all nodding your heads. I'd love to hear your thoughts about that and how we can improve our models by including some of these other dynamics, population dynamics that are associated with what we're seeing.
Danielle, did you have a question?
Yeah, thank you. I've been thinking a lot about the data gaps that are being kind of a theme of a lot of these great presentations. And I'm curious, it's clear that there's motivation to understand the magnitude of climate migration. And I would love to hear from the panelists a little bit more about one of the measurement problems seems to be the issue of then to get that measure, we have to have individuals that are climate migrants. And what is the value of labeling someone a climate migrant, if even just stopping it just to understand the magnitude of the problem? But I just love to hear a little bit more about that label and your perspectives on it. Thanks.
Any other questions in the room? Okay, there's one last one online, which I'm going to read out, and then we'll take it back to the presenters to talk. So the last question is, how are you thinking about the role of public policy, both de jure and de facto, in your modeling, and how the policy relates to perceptions prospective migrants have about their prospects, often mediated through social networks and media? Okay, speakers, over to you.
I guess I'll tackle the past as prologue. I think it's a really good point, right? Is that I'm definitely someone that builds statistical models based on the assumption that the relationships that held for long enough to build that model, or are at least reasonable approximations for the future. And I think it's a really good point that, you know, in both the climate space and the broader social human space, it's quite possible that both systems are simultaneously moving out of a space where that's a valid assumption, right? So yeah, certainly if you see a sustained, you know, decade scale decline in precipitation, I mean, even 10% would be, you know, presumably disastrous. You know, how much can you even model how that would ripple through an agricultural pathway? But yeah, I mean, you know, and I think this is sort of coming up more and more. I think, you know, a lot of people have touched on this, is like, as a pathway, is that even the pathway that's most likely to be operable once we reach some of these end of the century climate impacts, right? How many people will be relying on farm smallholder agriculture for food security versus doing something else in a city or something like that? And then the question, you know, becomes, okay, could we get ahead of this and think, all right, and Cascade would be one of the people to be doing this. Can we get ahead of this and think, all right, what are the consequences for these changes we're predicting in an urban environment, right? So heat is obviously a big one. But also, you know, somebody is providing cities with foodstuff. And so how does the, you know, urban rural connection of food systems work? So, yeah, this does suggest, I agree completely with both of you, that a concern is that the system is moving out of a space for which the sort of transfer functions we're working on are you know, valid anymore.
If I have 1 minute, I would like to address the question about who are these climate migrants. And so the point is that exploiting statistical models, where what we do is basically analyze the variability of climatic shocks and how these affect the variability in migration, we can actually see that there is a relationship. So we see that these people move because of climatic drivers. So that doesn't mean that other socio-economic factors are not affected, but we need to distinguish between the direct and the indirect role of climate on migration. So a direct role means that there is, for example, a flood, there is sea level rise, so nothing else happens, and people are forced to move because maybe they don't have the house anymore. And this is the direct effect, and nobody would question that there is a relationship between the shock and the choice to move. It's more complicated if there are other types of indirect relationships. So that's typically occur when there are slow onset events that, as was mentioned before, people don't even realize are happening. So that means that these type of shocks are somehow affecting some economic factors, and these ones are pushing people to move. But we still think that the major driver, the initial driver, is the climatic shock, even if there was this kind of intermediate steps that end up that force people to move. And the type of model that we use, again, these are not just correlation analysis. So these are statistical models that try really to understand not only the direct, but also this indirect effect of shock on migration.
I can, if we have 1 minute, I'll just add some concluding points. The question of urbanization and like what, you know, structural factors that exist outside of climate change is one I ponder often. And I guess I'm trying to make that point as clear as possible that what is the marginal effect of a climate shock within our current globalized economic system? And I think that's location dependent. And I think I have a colleague here at Montana State University, Elizabeth Nelson, who goes out and does qualitative work in the deserts of Algeria and talks to young men, and they never bring up climate change as why they want to move to a city or move to France. I mean, it's aspirational, it's culture, it's media. She has a great story of one person she interviewed who just really wants to move to a city because they want to start a band. They're young people. It's what young people want to do and have wanted to do for a long time. So I think that those structural things, irrespective of climate change, are really important to include because, as I said, I think some governments might start blaming all their problems on climate change when it's not necessarily a climate problem. And then the last thing I'll say regarding labeling people as climate migrants, I think that becomes really important when we talk about loss and damage and climate attribution and holding actors who cause climate change accountable. And so while it could be viewed in the pejorative, and it very well by bad actors will be taken the pejorative, like if you actually want to give people, their fair share of any sort of loss and damage who are affected by climate change, then you need to identify who's affected by climate change and who has to move because of it. So small island states are the easiest example to think about, but we cause this problem and other people are being impacted, and we cause this problem every day through our actions. What, as an individual in the West, do I have to pay into that to help reduce suffering to people? I'm not sure of that, but I think those questions will become really relevant and are becoming relevant. So labeling people climate migrants or not is going to be challenging, but it does have a real ethical and just issues of basic human dignity that I think are important to think about.
Yeah, I'll just add to that in the Central American case, that label is important potentially for asylum and for the legal status of migrants. And as I think Elizabeth said, right, the nature of migration, again, in the Central American context, I can't speak to Europe or the Mediterranean or elsewhere, but the nature of migration has changed. And Diego, you were kind of getting at that as well, right? That the motivation for people coming, the nature of how long they would stay, the securitization of migration and the sort of militarization of the border, this changes the push-pull factors that are operational even over the last few decades. So this does raise this question about, are we right now at a place where labeling climate migrants means one thing within the current context of those push-pull factors, and how might that change in the future, and how might some of our actions now have unintended consequences, right? I think there was a comment in several years ago about the nature of this, right? That securitizing climate migration risks, cascading effects on in the arrival countries. So I do think we need to think about the nature of those push-pull factors and what it does mean to be a climate migrant and what the consequences of formalizing that label are. And I think, loss and damage is obviously legal status. All these things are important. National policy around borders.
Excellent. With that, we've reached our time. So Kevin, Christina, Cascade, thank you so much for your valuable contribution to today's conversations. With this, we'll close session 2. Thanks, everyone.
Thank you. Appreciate the time.
Thank you. Bye. Bye-bye.
Yeah.
scientist at the University of Denver, and I have the honor to present you with the session on transdisciplinary research, hoping to bridge some of the gaps we've been discussing in a little bit of an advantage there because we can reflect on the previous sessions right now. But it's my honor to introduce you to Dr. Diana Liverman, Dr. Catherine Donato, and Dr. Pierre Genton, who are going to be speaking both some here in person, obviously, and we have Diana virtually. Diana, if you're ready, we're going to go ahead with you.
Okay, thank you. I'm really sorry I'm not there in person. I'm speaking to you from Tucson on the unceded lands of the Tohono O'odham and Yaqui. And I have a sort of cluster of remarks. I'm not going to use PowerPoint. And I'm glad about that because some of the points have already been made and I don't want to repeat them. But I want to begin by inviting you all to think about your own migration decisions, whether you have migrated within your country or, like me, have crossed the Atlantic several times, or to think about, is there a way in which climate change, you can imagine that it would cause you to migrate? And when I reflect on my own migration decisions and those of some of my friends, climate is not what comes to mind. I'm very privileged. I have a lot of advantages. I first migrated with my family from West Africa to England, but I've also changed. I've been mobile in response to a sense of adventure. That's why I came to graduate school in North America. I've moved for jobs, for economic opportunity. I've also moved for love. I think a lot of people do move across the world and the country because they've fallen in love or fallen out of it. I think that I've moved back to England to care for my family, and climate has never really played a role. Although with it into somewhere I live, the long tradition of migration, of course, is snowbirds who move to a warmer climate from Canada and northern parts of the United States. And one of the things that happens to me fairly frequently is I'll sometimes get a call from a realtor who's trying to sell a house to a migrant from further north, and they want to know whether climate change is going to make Tucson uninhabitable. And my usual answer is yes for the vulnerable, but probably the people who you're selling a house to have the funds to have buffers against climate change. So I wanted just to think about if I was asked, were any of my migration decisions climate related? Will any of my future decisions be climate related? And then I think the other question, again, to sort of bring it to people's individual lives, is why are we interested in climate and migration? Why are we studying it? I mean, it's intellectually fascinating because it's such a complex issue. But many of the people I know in this area are also studying it because of their humanitarian concerns and their empathy for the suffering and the challenges that face migration. And like Cascade, I got interested in climate and migration when I was growing up. I'm a lot older than he is. For me, it was the devastating droughts in the Sahel and the migration flows in the 60s and 70s, and then continued to stay interested in it. And I'll come back to migration being sort of marginal to my core interest in vulnerability and livelihoods, but what I've learned about the climate migration link. But I also want to give a little bit of a response to being put in this session on transdisciplinarity. And it caused me to think a bit about interdisciplinarity and transdisciplinarity, and also to be a little bit annoying by talking about my own discipline, which is geography, and its sort of tradition of looking at climate and society and climate and migration. So I think of interdisciplinary work as when I'm on a project and we have people from different disciplines. We try to come together for a shared conceptual framework, and we write our articles together. And I think some people use the term transdisciplinary for that. But my understanding is that transdisciplinary collaboration involves non-academic partners who are co-producing knowledge together, who have a commitment to action. And so I'm going to focus a little bit in my lessons on lessons of trying to do transdisciplinary research beyond the academy. But let me be a bit provocative and say that to some extent, the research on climate and migration links needs geographers, because whilst you can do interdisciplinary research, the value of geography, I think, is that many geographers are trained both in earth science and in social science. I certainly was. I had a lot of training in climate science and then shifted more to social science. And whilst graduate students specialize more now within geography, I also like to see students interested in climate and society have enough of a background in climate science that they don't have to start from scratch when they look at these questions or go into an interdisciplinary field. So one of the things about being a geographer, and many of the people here are, and geographers dominate, for example, working group 2 of IPCC, is this cross-training in earth and social science, cross-training in quantitative and qualitative methods, doing work that ranges from modeling to ethnography, which my own career has covered, looking at behavioral approaches as well as critical approaches, and a lot of attention to place and to scale, looking at how we can connect the global to the local. And there's also this very long history of studying environment and migration, not just in geography, but also in anthropology. And sometimes it feels like this climate migration debate is very recent, and I'll review articles that say this is a new challenge, and it really isn't. I mean, we've been looking in a number of fields at seasonal migration for 150 years. People have been trying to understand transhumance, seasonal migrations in response to climate variability, where mobility has been seen as a normal practice, not a crisis practice. Migration has been written about as an adaptation to a varying climate for many, many decades. And people have already mentioned the risk of a sort of climate determinism. And part of the reason some geographers have avoided working on climate and migration, and perhaps also people from other fields as well, was at the turn of the beginning of the 20th century, were these truly sort of racist and discriminatory studies that were coming out about how climate not only causes migration, but affects human intelligence and the economic potential of nations. And so the interest in climate and migration, or climate and society, sort of disappeared for a while, partly from geography because we were embarrassed by some of this climate determinism work. But we still see, particularly when people are new into the climate and migration field or climate impacts on society, you can still see some forms of neo-climate determinism. And we have to be very careful about that. Then another thing that I've become a sort of a, old fart reviewer in some ways, because I'll often be sent an article to review that doesn't look at the deeper roots of research. And I mean, one of them is the sort of hazards tradition in the social sciences, where people work very closely with their colleagues in the earth sciences to understand the impacts of drought, the impacts of flooding. And that's been going on since the 1970s. And there are really fantastic studies that we need to go back to if we really to understand some of these climate migration linkages. And it's particularly the history of our understanding of climate vulnerability. And that's where migration started to pop up when we were working on trying to understand what made people vulnerable to climate, particularly in my research looking at farmers. And one of the adaptations that came up was, oh, well, sometimes we'll migrate, or we'll go to the city, or we'll go to work in the United States. I've done a lot of work in Mexico. And so it came up not because we said, is climate change causing migration, but how is climate change affecting livelihoods and how do they respond? And some of the rest of you talked about that. I do want to highlight a conceptual framework that's been very important to me and a number of geographers in understand climate society relationships, and that's the framework of political ecology, which for me is pays serious attention to agency, which was already mentioned. It pays serious attention to the physical environment, but it also pays serious attention to the political economy. And so I want to propose that for transdisciplinary research, coming from a starting point of political ecology can be a useful framework. And there's actually an enormous amount of really great qualitative research that helps us understand livelihoods and the way in which migration might intersect with those. The final thing I want to say about geographers and some of the other social sciences working before I talk about some of the other lessons learned, and this has come up in things several people have said, including my colleague Kevin, is the downside of the climate migration discourse. And I received a fellowship from the SSRC back in the mid-80s to look at environment and security in Mexico. And back then, it was very clear that migration was starting to be seen as a security issue related to environmental change. And I got into quite a lot of debates with people like Tad Homer-Dixon, for example, who were really and Norman Myers, who were already presenting apocalyptic migration stories in talking about climate change. And several things emerged from that. The risk of securitizing migration, that you can use the climate migration discourse as an excuse to militarize borders. It's been weaponized against migrants by actually some very distinguished scholars who are concerned about immigration. Kevin started to hint at an issue that I now recognize as being very important, which is the ethics of talking to people, talking to migrants about whether climate is playing a role. And this comes from working with my colleague Liz Oglesby and a workshop that Kevin and I and Liz organized on Central America, where it became very clear from some of the people who were working on asylum cases that you have to be very careful not to put the idea that climate change could be responsible for migrating, because if they say that in their asylum hearing, they'll lose their asylum claim. And I thought, oh my gosh, I can't go talk to people in the shelters about whether climate change is affecting their decisions, because that could really affect their lives and ruin their asylum hearing. And then I think the final thing that Liz always emphasizes, she's an expert on Guatemala, is the way in which the climate migration discourse can let some really evil people off the hook, some really bad governments can say, oh, well, it's drought that's causing the migration crisis. It's not the way in which we're violating human rights, and so on. So just to move to sort of the second set of comments, I wanted to just come up with a set of points, trying to avoid the ones that have already been mentioned, about what I've learned about studying climate vulnerability and perhaps migration over the years of working on vulnerability to climate change in Mexico. And I've learned an enormous amount from my former students like Karen O'Brien and Hallie Eakin, and from colleagues like Kevin and Liz and others. But my focus, as I said, has always been to understand the farm livelihoods and the communities they lived in. And I would say that our biggest insight was when we were trying to understand adaptation to drought and climate change, was that migration, seasonal or permanent or transnational, was an adaptation. And it's in Mexico, it's a very, very long-term adaptation strategy to migrate in response to climate variability. But here are a few lessons, and I'm just going to go through them, and then people can ask questions if they want in the Q&A. One of the things that's so important from the climate science point of view, and people have talked about this, is using multiple data sources to understand what's happening to climate. I'm very excited about the use of imagery and emerging satellite opportunities to understand that. The lesson I learned about using station data was when I was working with Karen O'Brien in Chiapas, and we actually went and visited some of the met stations that were being used to look at climate change in the region. And, we found people hanging their laundry over them. We found donkeys drinking out of the rain gauges. I mean, a lot of those met stations, we found met stations where a completely untrained person was taking measurements for a variety of reasons. For that reason, I think it's so important to include local knowledge and local officials in trying to look at what's happening with the climate. And there, I think there are really important challenges, and Talia and I have talked about this, about whether the earth scientists can really help us capture what local people tell us is important in terms of their agriculture, for example. So can we model and observe the summer drought in Mexico and Central America accurately enough? Because what I heard from farmers was that was really, really important in their farming decisions. Also, the date of the onset of the monsoons is so important in northern Mexico. Second thing is to understand the environmental and social history of the communities. And my lesson there was a number of years ago, I was part of a study on the drought of the 1950s in northwest Mexico, very severe drought. Everybody was assuming that that drought was the main cause of increased migration to the United States. And not one person had realized that the onset of that drought was the onset of the Bracero program. And when we actually did interviews with people about their memories of the 1950s, they're like, oh no, it wasn't the drought. We were invited to come. There were people down, taking us to the United States. And they said it probably would have been fine if we'd stayed, but we were invited. In terms of a few lessons about doing the social science side, I think the thing that I've learned is before you design your survey, you need to go listen to some of the communities, and don't go in with I'm studying climate change. Go in and talk to people about their livelihoods and the stresses on their life to find out if climate change is even a salient issue for them. And you can completely redesign your survey. And there are techniques in social science like repertory grid, where you ask people how these two farms are different from this farm, that allow you to understand a lot more about how the community is perceiving the issues that matter to them. Another thing I always push students to do when we're studying rural livelihoods, including migration, is don't just talk to an individual about their decisions, talk to them about their neighbors' decisions, because you often learn a lot more by triangulating to get people to gossip and to talk about the people around them. You'll get often more accurate information, whether it's about the role of narco trafficking or what people's incomes are, getting them to talk about someone else. Couple more things in terms of both large-scale survey studies and the sort of statistical studies that correlate climate and decisions. Another thing that in reviewing articles on this that I often notice is people are always looking for the fit and they're not looking at the outliers and anomalies. And I think it's really important to look at the things that don't fit the trend or don't, the people who said something unexpected in the survey. And I don't think we do that enough. A couple more done triangulation. One of the things I don't think anybody's mentioned that we uncovered in a lot of the work in Mexico was, yes, migration is an adaptation decision for some people, but adaptation where people send back remittances is extremely important form of adaptation. The money coming back to the communities is allowing other people to stay where they are. And then I'll just make two more points. One is if we're doing truly transdisciplinary research with people beyond the academy, we need to think about what we're going to give back so that we're not doing extractive research, whether it be with Indigenous people or with scholars from the region that we're working with. And there are a bunch of ways you can do that. We've given materials to schools just as a thank you. You can hire locals. You can make sure that you put local colleagues and even non-academic collaborators on your articles. There is a challenge for the US funding agencies. It's sometimes very hard to put resources for your collaborators into that. And then the final point I want to make that we were starting to approach in the discussion about urban areas is one of the things I've learned from fieldwork, whether it be in Tucson or in other parts of the world, is that climate stresses that could trigger migration often come from outside the region. So in a city, it's going to be what's happening in rural areas that's affecting food prices that can throw people into poverty and have them considering migration. But it's also transnational. And the lesson I learned there, I'm wrapping up, Lyle, the lesson I learned there is from NAFTA, is that one of the things that triggered migration in Mexico was the opening up of the maize markets, where maize prices went crazy, and that was transnational vulnerability to both policy and climate change. So I'll end there. Thank you very much.
Thank you so much, Dr. Lieberman, for your insightful perspectives. We're going to continue with Dr. Donato. And remember, we'll have the Q&A after the session.
Okay, you'll start it, right? I think that they will start it. Thank you so much. Thank you for the invitation to be here. Very excited to share this collaboration with you. Let's get to the first slide. Okay, so this is a project that I'm going to talk about, which is definitely a transdisciplinary research project, research collaboration. It's a part of the world that I never, frankly, thought I'd be working in until about 2010, when someone in the Earth Sciences Department at Vanderbilt called me on a hardline phone in my office and said, would you come on over across the quad? And we started a conversation that led to a big grant proposal. And so I am going to talk about the relationship, because there were a number of people working in Bangladesh for about 15 years, and geologists, engineers, and earth scientists, and they were looking at the physical landscape changes, and they wanted to bring in the human, and said they never talk to people when they go and collect data, so they needed a social scientist. So, I mean, broadly speaking, I've been looking at this question with them in this larger group. How is climate and environmental change affecting patterns and processes of demographic outcomes, including and emphasizing migration in Bangladesh? And we're doing a series of papers. I'm just going to highlight a few as we go forward. This is a picture of, or various photos of the current team. This does not include Steve Goodbread, who is a faculty member at Vanderbilt who called me originally. But this is the current team, and I know Lori will recognize some of these people. So we're focusing on Bangladesh. I know a number of people, both here and on the Zoom, understand this country, know this country. I've been there several times, going back for most of June this year. And as you can see, there's a major river that cuts the country almost in half. And we have been focusing on the southwestern part of the country. Lots of people living there. Population density is one of the highest in the world. About between 70 to 80% of its population in rural areas, 70% of the land is agricultural, et cetera. And you can see agriculture still contributes a fairly sizable share to the GDP. It is the world's largest delta, and which means many things, some good, some bad in this context, right? It's very fertile in some areas, but it is a very dynamic physical system with low-lying sedimentary landforms, and this delta regions, right, will, as suggested by a number of large-scale reports, will face severe disruption by the end of the century, if not by mid-century. And, many people write about sediment, but this is sediment and freshwater delivery going from the north to the south. And of course, it really, the system extends well beyond the northern part of the Bangladesh border. But what's happening is it's a fair amount of threat. There's a lot of dynamic movement in sediment and freshwater delivery. So here's what's happening in this delta at the moment. It's hard to, at any given moment, say exactly this is more important than that, but there are lots of physical processes that are active. And leading to lots of salinity. In fact, we always ask a question, as you'll see in our survey, about salinity, and not everyone, 85% of the sample reports repeatedly that their water is not saline, but yet there's a tolerance, right, for a high salinity in these places. This is also an area, especially the southernmost part of the and you can see in that little map to the right, the southernmost part of southwest or South Bangladesh, that has been, there have been attempts to manage water there. And, both soft and hard infrastructure, from mud burns, little pathways to protect rice paddies, which were torn down every year and then rebuilt. And then in the 50s, Bangladesh, with USAID funding, constructs earthen embankments, right, with some concrete blocks, and then eventually the Dutch come in and build these embankments, levees, we would say in southern Louisiana, polders, the Dutch calls them. But they were constructed, you know, in about a 20-year period, and many of them have not been maintained. There are many breaches. Oh, and I just wanted to point out, the blue areas are all in poldered, right? There's some version of a levee around those areas. Now, migration has been pretty, you know, it's been a form of adaptation for many, many years in this part of the world. There is, you know, both for economic opportunity, but also for different environmental stressors. So migration can both be a sign of system failure, desperation, got to get out of here in order to protect my family or take care of my family and myself, or it's also remittances, as someone just said in the last session, right? Remittances, or maybe it was Diana actually, remittances really strengthen many of these communities. And we're just finishing a paper on remittances now, which I'm not going to show you, but the numbers, we're projecting out what the remittances look like in the past and in the near future. And the numbers are pretty astonishing. So this project, broadly speaking, is trying to connect the physical and social landscapes. So we were able, after the first funding with Steve and everyone else from the Office of Naval Research, we received funding from the National Science Foundation. We, you know, as we were writing that proposal, we wrote that proposal in 2016, late 2016, early 2017. So the Rohingya had not yet arrived in Bangladesh. So we really had to think about because I'm a social scientist and a demographer. So I approach this question from that kind of disciplinary perspective. And we had to think about what kind of migration movement are we trying to capture. So in this project, we capture both planned movement, even if the planning is only a few days long, and as well as circular migration. And we count someone as a migrant if they have set up a household somewhere else for at least 3 months or longer. So that's the type of migration we will capture here in this project. So we won't capture very short-term moves, for example. But then the question is, how do we measure that migration? And as everyone pretty much has said in every session, right, we need to capture this in a way so that it varies temporally and spatially, and to permit integration and merging of data from the physical science world. And then we also have to have detail about households, because if we only stay, and many of us do, and I understand, but if we don't have household level to integrate data to integrate into our analyses, then we don't have those individual identifiers and sometimes the meso level information. So in 2013, we fielded the Bangladesh Environment and Migration Survey. We call it BEMS, and that was BEMS 1. And that was largely a pilot that we did to see if it would be possible to integrate the kinds of data collection methods that I've been part of and Beth Fussell has been part of years ago in Mexico. If we could collect data in a similar way in this context. And then I'm going to report all the data, all the findings I'm going to report are from BEMS 2, which is where we were in the field for mostly 2019, and where we collected information for 4,000 households in 20 different sites. You see the dots of our sites there. We chose our sites to reflect a range of socioeconomic and environmental conditions. So we were trying to sort of choose sites that varied on the relationship between socioeconomic status as measured by literacy and the percent of people in that area that graduated with secondary school, as well as environmental stress. We chose 200 households in each. We surveyed most of the survey responses are from household heads and spouses, and the emphasis is on retrospective life histories. And to give you an idea, so we are collecting migration history data. We are asking for every person is a long row, and we ask about their first trip and their last trip. And we tried to ask about the second to last trip. We were not as successful there. But these are trips that can be domestic, can be international, and you can see in the columns going across that those are, the attributes of trips. And then we have other tables that focus on some trips versus others. And then we structure the data in a way that allows us to really consider the person's life course. So this is one person, as you can see by the left-hand column ID number, it's the same. And this is someone who is age 24 at the time of the survey. That's the bottom row. And we can observe that person in every year of their life. And by doing that, then we can attach, detailed weather, meteorological data, and other kinds of data that are specific to year, and then we can attach that to the year of their life. So we know, for example, if someone went, as this person did, from a fisherman to a rickshaw puller, because they moved to Dhaka and then returned, we could then look at whether or not there was a particularly intense monsoon or a particularly intense cyclone that occurred at those times of transition. This is, just gives you a sense of the probability of making a first trip. So this is not all migration trips, but a first domestic and a first international trip. You can see, and this is men only. At the time of survey, they were between the ages of 15 and 44. And you can see that domestic migration is both are growing, but it's really in this area of the world. It's a lot more domestic movement, internal movement on a first trip. We're now modeling first versus last trip for a smaller group of person years to see if we can do this kind of work and understand whether or not first trips lead to second international trips and what's driving those international versus domestic second trips. So is erosion, so I'm just showing you a few select findings. First is erosion associated with rates of outmigration? Here we're estimating these discrete time event history models, really thinking about how erosion relates to risks of household heads making a first trip in a given year. We're controlling for a time and community fixed effects, clustered standard errors, et cetera. You can read it all. We created an erosion variable from remotely sensed data, where we were actually looking at the distance from the center of the village to the river channel and looked at that over a period of time from 1998 to 2017. Again, to look at change, right? And then we have all sorts of covariates you can see here. And this just gives you the baseline models. And we can see that erosion predicts an increase in the risk of first domestic trip migration, but there's a weak and insignificant effect for international trips. Then what we did is we generated a series of interaction models where we're looking at, again, following what many people have talked about, an agricultural pathway. We're looking not only at agricultural livelihoods, but whether or not you own land. And just a few kind of broad points. First, you see domestic first trips versus international first trips. You can see on the whole, the bars for the domestic trips are much higher than international, but you can also see the green and the orange bars that refer to medium levels and high erosion levels above 1 standard deviation. And you can see much higher risks of making a first trip. Much lower risks if you own land, as we might expect. But we see some patterns that, frankly, I've revised, I've redone these models so many times, and they're there. They're associations, I understand, but they're strong associations. The second set of findings, you know, in addition to migration, well, no, let me stay with migration, are heat waves associated with making a first trip? And then could extreme weather exacerbate early marriage? Again, I don't have time to lay out everything. I'm just showing you some figures here. This is the piece we published a while ago, where you can see this upward trajectory as the duration of heat waves extends over days. You can see, you know, an increased risk of making a first international and domestic trip. The relationship is certainly stronger for domestic trips. Could extreme weather exacerbate early marriage? Yes, in fact, we see that. We don't quite see it as much for the 11 to 14-year-olds. Getting married at that age still occurs in Bangladesh, but it's far less likely than it used to be. But we see after 18 days, for most of these trajectories, you're looking at increased risks. And then finally, you know, who are the environmental migrants? You can see here in the heat affected years, we're looking at 2 years after a cyclone or after a significant flood or a drought. And you can see they're older, they're more likely to be married, they're more children. They're more likely to have a household head who works in agriculture, does unskilled work, and is, you know, has their own business, and they go to Dhaka. So now we are moving into phase 3, let's say, of my Bangladesh work. And we have received additional NSF money to do a longitudinal follow-up with about 1,500 households. We just collected the data. The focus here is to look at how migration impacts, has different kinds of impacts on origin communities. In particular, we wrote this during these months of COVID shutdown, when we were very worried about the hundreds of thousands of Bangladeshis who were being repatriated back, and their communities are what we know they are. So we are really interested in trying to sort of parcel out the large-scale return migration and its impact on land use and well-being. So we've just collected the data, or 22 to 23. We now have the data, and we are doing a wide variety of analyses, including looking at other outcomes that I haven't talked about. Thank you so much.
Thank you so much, Dr. Donato. Last but not least, Dr. Shinton, if you may. And please remember to post your questions online. We're going to be reading those after this last presentation.
Great. And thanks a lot for the invitation. Thanks for the organizers and for the staff for making this happen. So to wrap up the day, I hope you're still awake at this time. I wanted to talk a little bit about climate extremes, how that could be actually pushing for climate adaptation and migrations, and thinking about the uncertainties that we have behind a lot of them. Kevin actually alluded to that, and then trying to wrap up wearing my NSF Science and Technology Center Director is thinking about transdisciplinary type of research and why it's difficult, how can we move forward, and how that can be potentially helping the community. So it goes without saying, and we've been alluding to that multiple times already during the day, that climate adaptation is needed. We're witnessing more and more flooding events. So for instance, took also that example, for instance, from Pakistan. We can think about more and more heat wave events and droughts. Thinking, for instance, about the Mediterranean, where we're witnessing basically more and more prolonged droughts and more intense droughts, or even new types of events. So something we've been witnessing, for instance, in New York City, thinking about wildfires and the smoke associated with that. But for adaptation, we require 3 kind of key components, right? The first one being we need accurate information about the future, right? We need to be able to be accurate in terms of the prediction. We call that a projection that we are actually making into the future. And for that, and we are going to be talking about that, we typically use climate models, right? So we use physically based models for that. The second component that's actually very important is, and we oftentimes don't really think so much about that, is we need to be able to provide data at scale, right? And in a very broad and easily accessible format, right? So if you're interested, happy to talk to you offline. We're actually developing as part of our LEAP Center some sort of platform so people could actually get access to data. The data would be on the cloud. They could even be doing the compute on the cloud and then getting access to the data. And we hope to actually provide that to the basically to a broad range of stakeholders, especially towards the global south. And that's very much needed because right now it's still very much of a niche, like how to actually get access to climate data and climate information. We sometimes don't realize that, being a bit privileged here. And the final point, and that's very much related to what we discussed earlier today, is that we need to have the capacity to adapt, right? And that's very much related to relocation and migration, right? Oftentimes we might not have the capacity, and I try to show you a couple of examples that to how the people that are actually impacting climate change the least are the ones that are being affected the most, right? And they might not have the capacity to adapt or even the capacity to migrate, as we discussed earlier today. So those are really the three buckets I would think that we need to think about when we think about climate adaptation. One way to think also about climate change is to think in terms of very aggregated terms. This is a very biased view of the world because this is in dollar amounts, right? So that doesn't really reflect the number of people being affected, but it gives like just a single value at the global scale. Thinking about perils, and in the insurance sector, they tend to think about primary perils and secondary perils. And it's very interesting to think about the fact that what used to be primary perils, so earthquakes, tropical cyclones, or windstorms, are now becoming secondary, right? And the secondary perils, which are directly connected and associated with climate change, such as convective storms, flooding events that we discussed earlier today, heat waves, flooding, wildfire, and droughts, are the ones that are having the most impact on a lot of the assets that we have, right? So there's really a change in mindset in terms of the way we are actually dealing with that. And I would argue that that would directly be tightly connected to also to relocation and migration at the same time. I'd like to point out that I think that's very important is that we have sometimes mechanisms that would actually be playing against us in the sense that we have climate change in the background, but incentives such as FEMA, for instance, are providing mechanisms that are beneficial right now, or that used to be beneficial, but we might not have actually the means to actually support that in the long run. And there's actually a lot of studies showing that now with that change, we might not be having the capacity to support that, especially at the federal level, for instance, in the US. So those are potential major issues in terms of major and rapid migrations or relocation. And we really have incentives that are limiting those relocation at this stage, but they could be lifted very quickly, you know, and so that's something to potentially consider when we think about that. So I'd like to start maybe with a few facts related to climate change. So we talked about that in various terms, but I just want to like pinpoint like some key aspects associated with climate change that are really pushing some of the boundaries of migrations or relocation and adaptation as a whole. The first one, and again, thinking beyond potentially long-term sea level rise, which is pretty obvious. The first one is thinking about precipitation extremes. And so one thing that sometimes we don't appreciate is that those extremes are not just increasing in the wettest regions of the world, they're actually changing across the entire globe, right? So we are actually witnessing more and more extremes of precipitation. So this is just an example here showing, for instance, in observations in the past, in dry regions, in observations and in climate models, and here in the wet regions of the world, in observations and in climate models. And at the top here, you have basically the change in the mean precipitation, so long-term mean, right? And at the bottom, you have the change in the extremes of precipitation. And they can be pretty decorrelated at times, right? So the important point is you have many regions of the globe where annual mean precipitation will not change or barely change, or it's not significant or insignificant, as Kevin mentioned earlier. But the extremes of rainfall are going to change. And that's very important because it means that there will be dramatic impact in terms of, for instance, flooding events, right? And we're actually witnessing more and more of those, even in dry regions of the globe, right? So despite the fact that we have, and that's actually written here as a summary of that particular study that I pulled over and pulled out here, extremes in daily precipitation are increasing pretty much everywhere across the globe, whether we're in dry regions or wet regions, and whether on an annual time scale, mean annual precipitation is increasing or decreasing or not changing, right? So that's basically a fact, you could say. The second, an important point, and that was not really discussed too much, but I'm glad actually Catherine just mentioned that just earlier now, is heat stress, right? And that's actually very important when we want to think about large-scale migration and population movement, right? This is typically a combination, heat stress is a combination between temperature and humidity, right? Typically, you would expect temperature to be following climate change, so typically increasing more actually over continental regions than over the ocean, right? The ocean is actually much more of a buffer, has a lot more inertia than the land, so there's actually much more warming over land than over the ocean. So when we think just in terms of global mean, we sometimes tend to have a very biased view of the world. We tend to have a lot more warming over land. And it's also a combination of moisture, right? The humidity in the air, right? It feels more discomfortable when you have more moisture in the air. So that's why when you're say in the wet tropics, it feels much more uncomfortable than being say in a desert, right? And it's very important because this is really what is killing people, right? That heat stress, so that combination of temperature and moisture. And you could look at different scenarios related to heat stress, combining that in different ways, and we can argue as to what is the best definition. There's still a lot of work being done there on the physiological aspects and components associated with that. But the main point is that basically this is increasing potentially, especially in the tropical regions of the globe, and those are the regions that are seeing the most increase in population, right? So there's this tight connection between where the people are and where we will have very, very large-scale impact of heat stress. And this is here just showing you the most, basically what we call extremely dangerous heat stress by 2100 on the right-hand side and 2050 on the left-hand side. And again, you can see this tropical band here, especially in wet tropical regions. And many of those regions are going to be very, very hard to live in and almost unlivable, right? So that's going to be affecting a lot of like large-scale migrations across countries migration. And we are actually already talking about a lot of migrations coming from those countries, especially in Europe and in North America. And that's an ongoing debate and source of tension. So you would expect those tensions to exacerbate into the future. I'd like to emphasize that this is a very complex issue, right? There's a climate component, which we need to understand, and it can be very uncertain. And I'll get back to this in a minute. There's a physiological component, which is very important, but it's also very complex in the sense that people can what we call acclimate, right? Typically, you die when you have a very sharp peak. So that's why, for instance, when a heat wave hit, for instance, the Netherlands, there was a very strong mortality. The same might not happen in Spain, right? Because people tend to acclimate, right? So that acclimation is also something we're trying to understand. People don't really understand it fully, but there's a lot of like transdisciplinary type research to understand the impact, even just of simple things such as heat and heat stress. We talked about a lot about that today, and I'd like to get back, and Kevin mentioned that very well, talking about droughts, right? And where do we stand in terms of droughts? Droughts are very important. Why? I would say the primary impact is going to be on food production, right? Food productivity is highly, highly dependent on water. We think a lot about temperature, but I would argue that water is almost more critical. We have a long history, for instance, with the Nile Basin, right, where people, and the Nile River, where people have been producing and having very large-scale agriculture thanks to water. And it's actually important to emphasize that, and Kevin mentioned that very well, is that those are actually results from historical data that in many regions of the globe, we are actually very uncertain as to the future of droughts, right? And I would argue that, I mean, you could argue that in most regions of the globe, we actually don't really know whether we'll have more or fewer droughts, right? And that's a major issue because if you're thinking about planning, reservoirs or dams, you know, planning as a source of or as mechanisms for adaptation, that's going to be a major issue, right? So we need to have a much more accurate view of the world and a much more accurate view of the future. Now, there are regions where we do know, and based on past record, but also on projections based on climate models, that things are going to change. They're actually highlighted here in those different boxes. So Central America being one, for instance, the Western North American being another region, or the Mediterranean. So those are regions where we expect to see an increase in drought. And when you actually just focus on those regions, you could actually see that drought intensity and frequency are going to be on the rise. And that's very unfortunate because those are actually a basket of many places across the globe. For thinking, for instance, about California or the Mediterranean, there's been actually very high value crops in those particular regions, right? So that's something to think about, and that's going to have a huge impact on food productivity and food price as well. And we will need to feed an ever-growing population. I'd like to emphasize, and that's also why transdisciplinary type research is very critical here, is that droughts tend to be what we call multifactorial, right? So there's not just one type of drought, right? We can have soil dryness, we can have agricultural droughts, all many different types of droughts. This is just an example here, like on fauna, the vegetation, or the soil. And so we really need to have a very holistic view of what a drought is, and thinking about this transdisciplinary type research if we want to think about the impact of droughts in particular and how that could actually lead to some impact, especially on adaptation and potentially on migration and food productivity in particular. I'd like to spend just the last few minutes on thinking about uncertainties. And again, Kevin mentioned some of that earlier today, is that we need to recognize the fact that current climate models, even though they've been extremely valuable, they received the Nobel Prize back in 2021. Manabe actually at the time for great innovation in terms of climate research, but they are still way too uncertain to actually address many of the questions we have as a community. And this is here just showing you one particular example, which is the simplest metric you could think about. This is basically surface air global temperature. So we take the temperature across the planet and looking at the ground level across different climate models that are participating in this couple model intercomparison project, the CMIP6 latest intercomparison project, which is used for the IPCC report, right? So you could think of that, this is state-of-the-art climate modeling here. And the unfortunate truth is that there's a huge amount of uncertainty. So the shaded area here is showing you the spread across those different models in the past, which is in blue here, and then in the future, so what we call a projection across different shared socioeconomic pathway, which are here on the right-hand side, okay? And the main take home here is that forgetting even about basically greenhouse gas emissions and basically shared socioeconomic pathway into the future, even by 2060, just the models themselves, the physical models are very uncertain, right? So it's not just the human behavior, it's also like just the physical system is actually very complex and difficult to grasp. And I'd like to emphasize this is what is used for the Paris Agreement. When we talk about 1.5 or 2 degrees Celsius of warming, we actually use those baselines, right? And I actually did that intentionally here in the sense that I also showed the uncertainties in the past, right? So there's actually a lot of work to actually use past record, and that was mentioned earlier today. For instance, Justin mentioned some of that, using past record to actually constrain a lot of the historical record and constraining climate models. People are starting to do that. There are some great studies in that realm. But the main point being is that things were also uncertain in the past, not just into the future. Now, when we think about adaptation, we think about migrations. It's not really a global issue, a global metrics that we want to consider, right? The impact is at a very regional scale, right? So we need to think at the regional level. That's where the impact is actually starting to happen. And again, if we think about some of the things that will have an impact, such as extremes, so for instance, precipitation extremes, I mentioned that they are on the rise. They will have actually a lot of impact on flooding events in particular. We can look actually at climate models. So this is one particular climate model here showing you the distribution of precipitation extreme in that particular model, which actually happens to be a good one or a very good one. And the main take home here is that if we compare to observations, which are here based on rain gauges over the US, you can see that basically that climate model is actually very much underestimating the extremes of precipitation, right? And there's nothing specific about that model. It's a very standard model in the sense that this is a very typical problem we find in climate models. They tend to way underestimate the extremes in precipitation. And so that has a major impact when we want to think about basically precipitation extremes, flooding events, and inundation. The models are really, most of them are not up to the task, right? So we really need to focus more and work more on that to actually improve those things. Just to emphasize that, so there's some hope here is that when you push the resolution, so typically the resolution of a climate model, and Kevin mentioned that really well, is on the order of hundreds of kilometers. When you push that to a few kilometer scale, which is more like weather forecasting, they tend to do a much better job at capturing those extremes. So there's some hope, if we were to push the compute or push some of the resolution. It's not a silver bullet, but it can help for some aspects of climate change, and especially some of the impactful aspects of climate change. Getting back to droughts, again, droughts in the past and into the future are actually very uncertain. So this was actually a very nice schematic based on the past IPCC report, showing as to where, so those are actually subcontinents here. So you should think of that. This is South America, this is Africa here, and showing you basically the significance level that we have in terms of whether we see an increase in in droughts or decrease in droughts, and showing basically the degree of significance. So the number of dots here is showing you the degree of significance. And basically, the best we have is basically in Western North America and the Mediterranean, where we have a medium confidence, not even high, right? So that's basically the lay of the land. That's what we are dealing with when we think about droughts, right? So what it means is that a lot more research and a lot more work is actually needed, so we can actually pinpoint those things, so we are better able to adapt as a society. And thinking really at the subcontinent level, because that's what is going to drive a lot of the migrations that we talked about. So we really need to pinpoint those things. That's very, very crucial. I'd like to close on that part of the uncertainties to think about the fact that impact is not just global or even regional, it's very, very local, right? You could think this is just a map of New York City. You could think even at the zip code level or even at the block level. As a New Yorker, you need to think about block. And this is here showing you just a map of basically low income and basically racial minorities. So you could think, for instance, like this is Harlem where I live, this is the Bronx here. You could think actually basically this is basically historical redlining to a large extent, right? And it's actually very interesting to overlay that basically with the extremes I mentioned before, like to think about heat extremes, right? Or to think about flooding events, right? And you could think of that because that's going to be where the impact is going to be. And if I just were to overlay that with a heat stress, right? This is during a heat event or like a heat wave event in New York City, you can see that they overlay almost perfectly, right? This is pretty mind-blowing to a large extent. So you can really see this redlining and racial basically a systemic and also a diversity issue that's actually directly connected to climate impact, right, and climate adaptation. I'd like to emphasize that this is very much due, for instance, to green spaces here in New York, but flooding is the same issue, right? Many of those places will actually be flooded much more frequently than the more well-off actually part of the city. And those are also basically places, and those are minor communities that are less capable to actually deal with climate change, right? So they might have actually fewer AC systems, or they might not be able to actually bear the cost to actually run those AC systems most of the years. I mean, or most days of the year. So there's a very clear redlining in terms of also the impact of climate change, is even at a very local level, and that's very, very far from where we can go now. So just to conclude, so extremes are on the rise, so it goes without saying. So thinking especially about precipitation extremes, heat stress, drought frequency and intensity, in addition to long-term changes, right? So I didn't really mention sea level rise, but that's an obvious long-term change. And that's especially true in the global south, but also even in local communities, right? Especially underprivileged and under-resourced communities. Those extremes will currently already have a significant impact on livability, right? So many places might not be very livable in the long run, on food productivity, and that's going to have a huge impact in terms of where people want to live. And that will have potentially tremendous impact on large-scale relocation and migrations as well. And basically, climate change is adding stress, as we mentioned before. It's not the only factor, but it's actually adding stress on already basically underserved and underprivileged communities. And that might be actually the tipping point that might actually lead them to leave a particular location. There are still a lot of issues, and I hope I convince you that we are still dealing with a lot of uncertainties, even especially at the regional scale and even more so at the local scale. And that's why Earth system modeling still need to be moving forward. We still need to invest in Earth system modeling. We're still not there yet to actually answer many of the questions that we have, and especially as we want to make climate change and climate adaptation and thinking about, for instance, migration in a much more practical way, right? So we are not there yet, I would argue. And that was mentioned before, so Justin very nicely talked about that. Data is actually needed, especially in underserved communities in many places of the globe, for instance, in the tropics. Kevin also mentioned that earlier. We don't have access to great records, for instance, of rainfall or heat. And those are actually especially critical when we want to think about long-term changes and constrain those long-term changes. So this is actually very critical, and we can really talk about data poverty in underserved communities. Finally, just wearing my STC director's hat and thinking about transdisciplinary type research to really understand the impacts of climate change, especially on migrations, but also adaptation. It really requires a great deal of transdisciplinary type research, right? So of course we have to deal with climate modeling or climate research, even historical paleoclimate. We also need to think about health, right? There's a lot of studies also showing the health impact, biology, ecology, sociology, economics, among many, and geography, of course. There are multiple challenges, so that's something we've been actually dealing with within our center. Vocabulary and jargon is a major roadblock. We very frequently don't think about that, but people have different views. What is a model for you might be a different thing for someone else. The training, right? Typically, we tend to be very siloed in terms of the curricula that we have. So how do we create that training? How do we make it appealing so that people will want to go into that type of training? There is still limited resources, right? We have some great support, for instance, from the NSF for transdisciplinary type research, but it's still limited, right? And it tends to be kind of a side project, right? Not your primary enterprise. So how do we actually incentivize this funding and also support a workforce, right? That's what we want to do in the long run. And finally, and it sounds maybe something kind of on the side, but how do we assess people, right? So typically scientists will have very clear metrics of success, right? How do we get into the, for instance, the tenure process, or we actually get a position? And the issue is that when you're dealing with transdisciplinary type research, people have different mechanisms and different metrics of impact, right? So how do you actually create mechanisms so that people can actually collaborate and then can have actually move forward in their career? So that's, to me, is a huge, huge issue and something we're actually dealing with, and we're trying to incentivize people to work across disciplines. So with that, I'll thank you.
Thank you so much. I'll ask for another round of applause for our panelists on the last session. I'm not going to try to recap everything that was said, but I do have some notes here, and I want to bring your questions as well. We discussed initially some reviewing the concepts of transdisciplinarity to avoid being constrained by those same concepts we're trying to put forth. So reviewing transdisciplinarity to also avoiding climate determinism was mentioned. Dr. Donato, you mentioned and you presented a very comprehensive assessment of your research, and I just want to highlight the timeline of funding that you have been demanding to reach this understanding of transdisciplinary research. And finally, Dr. Centeno, I want to just you mentioned capacity to adapt to what, right? And you mentioned that on the social side, and you mentioned also the variables that we're paying attention to, temperature, precipitation, but sometimes we have to also step aside from those temperature and precipitation constraints and allow ourselves for more discussion. So with that, I want to open the floor for questions on the ground. Justin.
Thanks, everybody. That was really wonderful. I guess this is kind of for Diana. I really appreciated your anecdote about weather stations in Chiapas becoming laundry lines. So I had a project a few years ago led by Ken Schultz, a political scientist at Stanford, on climate and violence in sub-Saharan Africa. And we noticed that a lot of weather stations went offline kind of after this post-colonial boom and bust. And so I wrote a bunch of weather ministries to kind of figure out what was going on there. And it turns out a lot of them closed owing to the political violence itself, right? These meteorological stations are kind of emblematic of state capacity and institutional capacity. And so they were going offline as fighting was occurring, to include like the weather records themselves, the paper they were printed on becoming a means to wrap goods at markets and things like that. And you know, from a modeling perspective, we were interested in trying to understand how temperature influences conflict onset in these places. And the fact that these weather stations were going offline due to violence itself meant that there was a massive endogeneity issue where it wasn't just temperature influencing violence, it was violence influencing our estimates of temperature. And from an empirical standpoint, that's like a massive violation of, and so I just thought that was interesting. And you know, there's a lot to unpack there, but it got me thinking about the parallels between this question of climate and migration and the similar investigations underway between climate and political violence. And I wondered the extent to which there were some insights from those inquiries, you know, or kind of the limits and the distinctions therein between climate and migration versus climate and political violence.
Thank you, Justin.
Do you want me to answer, Diego?
Yes, please go ahead.
Yeah. Well, just briefly, I mean, your comment on the status of Met observations in sub-Saharan Africa is really important. You know, for better or worse, the colonial control did keep a lot of those weather stations going, and then the economic problems of maintaining them are really challenging. And I sometimes think that we underestimate the importance of installing observation stations. And as Diego knows, our colleague Alex Guerra in Guatemala, he is putting in new weather stations because of the lack of observations particularly in the difficult topography. But he has a harder time getting money for that than for doing other forms of climate services. So I do think it's very important. In terms, I think there's an enormous overlap between the work on climate change and conflict and climate change and migration. And for me, the biggest challenge is that correlation is not causation. And I believe that we have to do more than the statistical work. We have to talk to people on the ground, and it doesn't have to be householders. It can be local extension agents or local NGOs to see if they are actually seeing this as causation beyond correlation. And I think similarly, we have to be very careful about our experimental designs. And I wrote an op-ed a few years ago. What about if climate change is causing cooperation rather than conflict? Because a lot of the research looked for conflict or looked for migration and then sought the climate explanation. Whereas what we would be, I believe, a more scientific approach is to look at where climate is changing and where it's not changing, and then whether there was conflict or migration. So I think we've had some sort of poor research designs in some cases, and those problems are common between some of the conflict work and some of the migration work.
Thank you, Diana. There's two more questions here in the room. Go ahead, please, Elizabeth.
Thanks. So I want to talk about something that Diana brought up, which was, you know, you spoke early on about climate determinism and the way in which people might have even avoided this topic because they didn't want to be associated with some of the colonial racist legacy of thinking about, you know, climate as being related to people, to racial characteristics or personal characteristics. And I thought that was very interesting. And I think that one of the ways in which we have sort of eluded that or avoided that, doing that is by using this word vulnerability. So, you know, Pierre mentioned our use of jargon. And I would like us to all interrogate what we mean when we say vulnerable, because often we think about, and so this is really a comment, but it is related to what you all have said. And when we say vulnerable, often what we mean are, we seem to be talking about vulnerable people as if those people had some characteristic that made them vulnerable to, especially vulnerable to these effects. Whereas I'd like to shift our perspective to say that the social systems in which we live create vulnerabilities that some people are more exposed to because of social inequalities. So that the characteristics, the vulnerability is really about our societies and the social systems in which we live. And I want to relate this to a point that Catherine made, which I wonder whether any of you caught her focus on the relationship between heat and early marriage, and wondered, like, what is the mechanism that would make heat, that would create that association? Why are young girls marrying earlier after heat events? And that is the social system in which they live, in which families regard girls as an economic burden. And so marrying them off is a way of alleviating that economic burden. So when there's an environmental crisis and people have shortages, financial shortages in their household, you marry off your daughters to alleviate that. And so are girls vulnerable, or are they living in a social system that makes them vulnerable because of the logic of gender? So I've gone on a little bit longer than a question, but I would be interested in hearing from you all on your thoughts about shifting that particular language, the word vulnerability, to taking a more social systems perspective and thinking about characteristics of society. And also figuring out which social characteristics, which social systems seem to be most tightly coupled with the environmental climate drivers.
Thank you, Elizabeth, and please hold your answers to that. We're getting into justice and we haven't addressed that. So I'm glad you brought it up. Laura, you had a question and then we can proceed.
It was specific to Catherine. I didn't capture what you used as your environmental variables. And so again, in the spirit of the workshop, I was wondering how you worked with your climate colleagues to come up with those variables and how you decided that they were the ones most appropriate in your study setting. Thanks.
Thank you. You want to answer now? I think we're all set. There's no questions online. So if you want to go ahead.
I'll have a quick response on vulnerability. I would actually argue that we've got a 40 or 50-year tradition of defining vulnerability as social. The term that I would use to describe people being in a place that means that climate affects them is what IPCC would call exposure. So the point that vulnerability is social and socially created, I completely agree with. And there's an enormous literature that documents that, both, on the ground and using multiple methodologies. And I will hand over to my colleague Catherine to talk about the early marriage case, but just to highlight that there's some really brilliant work been done in South Asia on the importance of caste and vulnerability to climate change, which has been sort of underlooked, I think, in a lot of research.
Thank you, Diana. Please go ahead, and we're going to close the session with this intervention.
Okay. Yeah, we've spent a lot of time, at least I as the demographer, right, was new to all of these indicators of environmental conditions. And because Bangladesh is both a place where there are clear climate change impacts in that we see, as you suggested, more intense storms. We see more intense monsoons. You know, we actually, in some parts of southwestern Bangladesh now, people talk about how there's more than one monsoon. When there used to be the summertime was the monsoon season, but now people are saying, well, there's always 1 month in January or February when it rains a lot. So this is complicated. We looked at all sorts of meteorological data that are available by day and obviously, you know, over time and by place. We went to various stations. We didn't see laundry on clotheslines there, but we did see a wide variety of conditions. We actually changed from the first paper we used, where we used some of the traditional meteorological indicators. We've actually then did some interpolation to clean up what we realized were some problems in the initial paper that we did. But we're focusing on heat stress largely. We're now looking at wet bulb. We're starting to do a paper looking at health of infants and young children because we have health data. We had, you know, in our initial modeling, we had indicators of drought or dryness as well. We had other indicators. Eventually, it just looked like in most of our modeling or all of our modeling, it was about heat stress. So we began to think, okay, above the mean or above the median amount of temperature, how many days beyond that? And that seemed like the best indicator. But again, you know, I'm open to having my climate colleagues tell me more.
Well, thank you so much. And I'm going to give the floor to our chair, Amir. Thank you so much, panelists. Thank you so much.
This wraps up day 1 of our workshop. I'd like to thank all the speakers and moderators for inspiring talks and great discussions. I think it's safe to say, based on what we learned, whether you're looking at climate and migration from earth science perspective or social science, we have huge gaps in our data and our models are not there. We need to work on them a lot. So there are huge opportunities, and hopefully our report will capture some of those opportunities for those who want to invest in this field. Tomorrow, we have 2 more exciting sessions. We hope that you all can join us for the rest of the program. And before you leave, please join us for a group photo right outside. Enjoy the rest of the evening and see you tomorrow.